Last class we discussed about the fiber connectors, three types of fiber connectors. What are they?
Okay.
Three types of fiber connectors:
SC connector.
straight tip,
SC.
square connector, and loosened connector, right?
Yes.
So that's the square. Okay. So we will be studying today about the single mode and multi-mode. We haven't studied what is single mode, what is multi-mode. I just want to show you how they look like, the connectors look like, okay? They are the only fiber connectors which are square in shape. Okay, so the outer part is square. That's where they get the name square connector. Now, this is the straight tip. Okay, and they will have this kind of BNC type of a connector where you just insert the cable and twist a little bit. Okay, but that's not the important thing. The straight tip. Okay, this is also a straight tip. Now, I said the LC, loosened connector, is going to be pretty much like a RJ45, okay, with the clamp. So that's the LC, okay. So these are the three types of connectors that you have in fiber, okay. Now, next is twisted pair. Twisted pair, pretty easy. We all know that RJ45 and RJ11. RJ45 is always used for networks, network connections. Okay. RJ11 is for telephone. Okay. They both look the same, but RJ11 is thinner when compared to RJ45. Okay. So RJ45, how many pins we have? How many wires inside? 8 wires. They are twisted into 4 pairs. Okay. Why is that? Why are the wires twisted? Any reason?
In 4 pairs?
Yeah, 4 pairs of even just you take 2 wires. Why are they twisted? Why are they just normally going in a straight line? Why are they twisted? Why?
Some straight and some twisted.
Some straight? No, there's nothing straight.
No,
Why? What is the reason behind twisting these wires like into pairs?
Receiving and transmitting, right?
Receiving and transmitting is not because of the twisting.
It's not interference.
For reducing the interference. Interference. In specific, it's called EMI, electromagnetic interference.
How it
EMI. Okay, when there is a flow of, when we say electricity is flowing, what does it mean? Electrons are flowing.
Mm-hmm.
When electrons flow, what happens? Negative charged particles, positive and negative, they start creating EMI, electromagnetic induction. Okay, so that in turn will have a negative impact on the voltage or the electrons that are flowing. Okay, if you this is only for copper cables. This effect is there only for copper. We never discussed about EMI when we discussed fiber, because fiber there's no electricity, it's all light. So there's no question about EMI.
So you lose electricity on the
It's not that you lose the electricity, your data is getting corrupted. How is your data represented? In voltages, right?
Right.
So what happens if someone corrupts that voltage? Instead of 5, if they make it to 7, if they make it to 3, your data bits are getting corrupted.
No.
Okay? So, in order to make it even, we twist the pair, twist the cables, okay? So plus and minus, plus and minus, plus and minus. So we eradicate the EMI, okay? So that's the twisted pair. That's where it gets the name as twisted pair, okay? All right, so we saw about the RJ45 last class, how many wires are there. Now, the two things that you have to pretty much remember for your exam, it's called T568A. These are the wiring standard. Now, there is an organization called TIA, EIA. They are the ones who actually define how the cabling should be. They make it standardized. Okay, because if no one standardize something, then we just go and make our own cables, which may not work. Okay, so they say, okay, if you want to do some wiring, now the wire should look like this. Okay, so they came up with a couple of standards.
EIA as well?
EIA. That's the organization. Now they came up with two standards called T568A and T568B. Now the only difference between them is the colors. Okay, T568A came first, T568B came second, but the difference is not in terms of who is better. They are both the same. Okay, this is where many get confused. Okay, A came, then B, obviously whichever comes next is better than the previous one. In this case, it's not the same thing. Okay, no one can say A is better than B or B is better than A, because it's not about who's better, it's about what color is being used in T568A cabling structure and in T568B cabling structure. Only colors differ, nothing else. You can still use, if you decide to use A, yeah, please go ahead. If you decide to use B, go ahead. No one is going to question you. No one is going to say, okay, don't use A. It's not better. No, nothing like that. Okay, so
Would it work?
sorry.
Would it work if I decide to use one or the other one?
Yeah, obviously, many still use T568A. Yep. It's not about who's better or whether it works or not. Both works. The difference, only difference is the color representation of those 8 wires. How those 8 wires should be. See, I told you in the last class. Okay, inside the RJ45 you have 8 cables, right? Now you cannot just go randomly picking up colors from 1 to 8.
Now, question. But if in one end, if I have a B structure, I have to maintain the same structure on the other end, right?
Okay, that's a good question. Now, in one end, like in this example,
Only one change, green and orange.
if you, okay, this is one end, this is the other end. If you make it as B here, T568B, and if at the other end, if you make it as T568B, so both ends are B, now it is called as a straight through cable. If you make one end as T568B and the other end as T568A, it is now called as a crossover cable. Now, who is not aware of the terms crossover and straight through? Okay. Crossover and straight through, these are the two most important types of twisted pair. It is nothing but the only difference is the color. Okay, like I said, combination of T568A. Now, if you take straight through cable, which means both ends are either T568A or both ends are T568B, which means if this end starts with orange, for example, then this end also starts with orange, because all 8 wires are colored the same, both the ends. So that's why it gets the name straight. Okay, the colors are same on both the ends. Now, if the colors are interchanged as per the standard, like one end is A and the other end is B, obviously the colors are interchanged. Now that is called a crossover. Now where do we use this straight through and crossover? So this is very important. If you are connecting two similar devices, okay, whenever you connect two similar devices, then you have to use crossover. Two similar devices. When I say two similar devices, two PCs, two switches, two routers, you need to use crossover, because the pin structure or the pins are changed, the pins are interchanged, so that if PCA transmits in pin number 1, PCB will expect to receive at a different pin number. You understand? Say for example there are 8 pins. Now this is PCA. and you're connecting to another PCB, and it has 8 pins. Now, say this is receiver, and this is for transmitting. Okay. Now, if this is also a PC, then obviously this will also be receiver, and this will be transmitting. And if you connect like this, straight through, now it cannot be the receiver. Okay, so this is not going to send anything actually. So this is the one which is going to send, right? So the cables should be interchanged so that it can go like this. That's for example. Okay, so that's called crossover.
So both pairs have to be switched.
Both?
Both.
Yes.
Sorry.
One end should be A and one end should be B if you are connecting two similar devices.
Yeah.
Always remember, similar devices crossover. Now if you are connecting two different devices, like a PC to a switch, a switch to a router, a hub to a router, now you use straight through. That's why you use a straight through cable. Okay, where both the ends either will be T568A or it can be T568B. Nothing wrong in choosing A or B, but both the ends has to be either A or B. So the cable will be the same on both the ends. The wires will be the same on both the ends.
Similar devices, it's a different.
Yeah, similar device crossover, different device straight through. Okay.
So you always need to wire, if now I'm getting another PC, I need to wire myself to make sure that the cables are,
Sorry, if you are connecting two PCs.
yeah.
Mhm.
And I just bought the cable already.
Okay, that is something these days called auto detect. Now
Okay.
it doesn't matter whether you are, but A plus doesn't discuss this about auto detect. Okay, it's not in your blueprint. Now today the cables are, I mean not the cables, the NIC cards that come out are auto detect. Like if you use a straight through or a crossover, they can detect and they will work accordingly. But
Before not?
no, not before. And you will not see that feature in A plus.
Yeah, I'm leaving in 2016, not to make one.
So that's a rule or that's a suggestion? That's a rule, right?
Which is a rule?
This one, if a crossover, if I connect a switch to a router,
Yeah.
right? That's different device.
You have
right?
to use a straight through.
You have to. If not, it wouldn't work.
Yeah, it will not work, obviously, yes. If it is not having an auto detect. Like if you are learning CCNA, someone who has learned CCNA, you will be doing some labs. You will be simulating and you will be doing some labs.
Yeah.
So when you place a switch and a router, you have to connect those two devices through a cable. Now you have to choose a cable. Okay, so if you choose a crossover between router and a switch, okay, it will not work.
Okay.
It will not work in the sense it will not show you an error. Okay, you are connecting a wrong cable, but when you try to configure them and send packets between them, it will not work.
How about what are similar devices like a printer and a computer?
End devices like PC and a PC,
Yeah.
router and a router, hub and a hub, switch and a switch.
Oh, it's not the type of device. So PC and computer.
Yeah, end devices.
Okay.
Two end devices, two routers, two switches, two hubs. They are, yes.
Okay.
Only with one exception. If you're connecting a PC to a router, that's the only exception. PC and a router are two different devices. So, okay, we will go for a
Straight.
It's a crossover.
Why?
That's the because
That's the exception.
PC and router have the same type of NIC. Okay.
How do I know in the cable? It says in the cable crossover or straight through. Like if I buy a cable.
You have to just look at these two colors.
Oh, you have to.
You will see these colors.
Yeah,
That's why
that's-
here in A plus they make sure you learn these colors.
That's not user friendly.
It is kind of. You will learn. You will see.
No,
that.
but I mean for someone that is not A plus certified or CCNA. I go
CCNA,
to-
forget it.
I go
CCNA,
to-
no one knows.
Oh, okay. I go to Home Depot and I just need a cable.
Okay, a person who has not done any other certification, he has just jumped directly into CCNA and is gone, he will not know this. Okay, because they never work on this. They don't have to know. That's the thing. If a person is a network engineer, no one is going to question him, okay, what is T568AB? If anyone questions him in that interview, he will just leave. Okay, why should I know this? It's because a technician who is going to crimp the cable and he is going to connect. Alright, because that's why these days we have auto detect. It should detect. If it is not detecting, you're having an old product. As simple as that. Okay. Alright, so let's just pick one. Okay. This is better. All right. B and A. Okay. So I think this is better. Now, all you need to remember for A plus is they are, even if someone has plans to do Network Plus, this is both applicable. Okay, for both the certifications, this is applicable. In Network Plus, you do get a lab, but in A plus, you don't get a lab. But in Network Plus, you do get a lab. Now, when you look at it first, yes, it's tough to understand, okay, or memorize the colors. But first thing is, all you need to know even though there are 8 cables, okay, now there are only 4 major colors that are being used. What are they? Green, orange, blue and brown. Okay, so first thing is you have to make sure you remember these 4 colors. Okay, green, orange, blue and brown. Okay, and we have that white, but not a complete white. White is getting mixed. Now, after we make sure, okay, I know all these 4 colors are being used. Now the second important point is, it doesn't matter whether it's a T568A or T568B, it's pin number 7 and 8 are always brown. The last 2 pins. Okay, the last 2 pins are brown. Alright, so that's the second important point. Now the third important point is the next color which starts, okay, brown, it starts with B. Now the second color which starts with B, that is blue. Okay, now irrespective of what it is, the type A or B, you see the blue being used in 4 and 5. So always 4 and 5 are blue. So blue and brown are not getting changed. They are same in both T568A and T568B. So only thing what you need to remember is brown is 7 and 8, blue is 4 and 5. So we are left with 2 colors now, green and orange. Now these are the only 2 colors that gets interchanged. Now important point number 4 is A will start with green and B will start with orange. Now if you can understand this, things will fall into place. A will always start with green and B will start with orange. So green and green, orange and orange. Okay, so at this point we know the brown, we know blue, we know green. So the only color left is orange, and the pin numbers which are left is 3 and 6. So orange goes here, and here the orange will be replaced with green in T568B.
Makes sense.
Alright, so if it's your choice to use both the ends as T568A or both the ends as T568B. If you use both the ends as same type, then it's a straight through. If you mix it, it's a crossover.
Sanjay, why is the all the colors are mixed together.
All the
except
colors are mixed together
yeah,
means?
green and white and green together and brown and
Yeah.
white together.
In
Like
pairs.
yeah, in pairs. And the orange is separated in the A.
Okay,
and
so
the green is
basically,
separated in
okay, basically when you use a Ethernet or a fast Ethernet, okay, even though there are 8 wires, now in Ethernet and fast Ethernet we don't use all the 8 wires. We just use two pairs. So which means we just use 4 wires for data transmission. And we generally don't use the other 4. Be it Ethernet or fast Ethernet. We don't use the 4. So mainly the cables that we use are green and the orange. Okay, so transmitting and receiving will be different. Okay, because if you're taking 2 different devices, obviously their pin structure is different. The NIC card that you have in a router, it's going to be different from the NIC card that you have it in a switch. Not physically. When you look, they look the same because the NIC cards are always the same. But if you look at inside part, okay, how the pins are arranged, they will be different. One will be a T568A type and the other one will be a T568B. So if you send something here, now it will go and connect like this. Okay, if you send something here, it will go and connect like this. Now if you send something here, it will go and connect like this, and this will go and connect like this. So 1 will connect to 1 will connect to 3. Now even here, 1 will connect to 3. 2 will connect to 6. Here 2 will connect to 6. Okay, so it's like that. Okay, so you need to make sure you understand the color structure. Okay, so brown is 7 and 8, blue is 4 and 5. If it is T568A, it starts with green. If it is T568B, it starts with orange. Now that's it. The other colors is going to be mixed between 3 and 6.
When someone installs these jacks here, over there.
It's me who install.
Sorry?
It's me who install. Yeah.
Like one goes to a wall, right? And the other one.
Which goes through the wall?
Oh, the one that you connect here. You're gonna have like a female here, right? Connected.
No, which one it would be?
Oh, it's not here in the wall right now, but it looks like this. Where the
All right. The socket. Yeah.
socket, right?
Yeah.
One of those goes
Something
to,
like this.
Yes. That one goes to the switch, right?
Yes. So the cable actually goes through the wall,
Yeah.
horizontal cabling, and it goes to the switch.
Switch. These they have to be different then because of what we talked here.
Oh yeah.
So this is one example of this crossover.
Yeah.
Ah.
Obviously, for patch panels, you will be using a different one. You will be using different types, either crossover or straight through. It depends on what device types you're connecting.
But then whoever connects have to know which cable the router is using so that.
So
then
who decides this? Network technician, who is the one who decides.
Okay.
Okay. Other than that, no one else. You cannot expect in a company which is based on manufacturing or finance company, and you cannot expect people who work in finance to know what cable to connect.
Sure.
They don't touch the cables. It's the technician who makes it fine. If it is not working, they just raise a ticket to the IT, saying that I'm not able to connect. That's it. It's not working. They will not even say connect. They even won't use that word. They'll just say, okay, I'm not able to work, or my computer is not working.
Yeah.
So it's the technician's thing to come and look what cable is using.
Yeah.
Okay.
But there should be a standard because in one company, I understand the crossover, but then there should be a standard that always a router is gonna have A or B. Because always the wall is gonna have this, or the technician comes in, oh, in this company they have it different. Here is B and there is A, no? Or it's a standard.
It's not like that, A or B. It will accept both.
Okay.
It will accept both. Now, if you are a technician, if you have your own IT department, you will have a separate box which has straight through cables. You will have a separate box of crossover cables, and you will just pick one cable and you connect. That's it. Okay, but these patch panels will accept both A and B. Yeah. Okay, so that is T568A and B, and we know the connectors 45 and 11. Next is coaxial. So as of now, we have learned 5 different types of connectors, 3 for fiber optic and 2 for twisted pair. The next is coaxial. Coaxial has again 2 types of connector types, BNC and F connector. Now these are, F connector is what you see mostly in your modems. We just saw the BNC connector, how it looks. Yes. Coaxial cables are used a lot, but not BNC is used in industrial applications only. We don't use it mainly, especially we don't use it in homes. The second connector, F, is what we usually see it in home, okay, connecting to the modem or the cable. But this is used heavily in industrial applications, like where you have to send a huge amount of data. You will see BNC connectors. Okay, so the difference is the connector type. Okay, you insert the cable, you twist it so that it gets locked. So that is BNC. Okay, that is BNC. Now, the next is F connector, and that's what we were seeing in the last class. So this is something we would have seen commonly,
Oh yeah.
right? So that's the F connector, which we usually connect it to the modems.
Yes, I was reading about RJ. Is there like 40, 56 and 59?
Yeah, they are there, but they are not in the.
No, not in the-
But they are RJ59. Yeah,
Well, what's the difference between 59 and 56?
59 and 56. The cabling structure, the pin structures are different, and the application is different.
Okay.
Okay, so that's F connector. Okay, so make sure you understand the names. Okay, so you will get a multiple choice question to pick the connector types under coaxial. Okay, it's always BNC and F connector. They may say ST connector, LC connector along with that. Okay, so if it is coaxial, you are going to mark BNC connector and F connector. So the difference between these two are BNC, you are going to just twist a bit and it's going to get locked. F connector, you have to twist or rotate the connector type until it's kind of a screw type, okay, until it gets tightened up. Right, so these are the connector types. Now next is something important. Now you will get one question for sure on this. We are done with the connectors, but I said we will be learning something about single mode and multi-mode. Now, fiber cables, we learned only about the connectors. Now, there are 2 types of fiber cables, okay, the 2 types. Now, how are the fiber cables differentiated? Now, we know inside the fiber cable how is data transmitted in terms of light. Now, who is the one who transmits? What is it made of? It's either glass or plastic. The inner core we are talking about. Okay, the core we are talking about is the one which actually transmits the light from one end to the other, and that core is either made of glass or plastic. So we are clear with that. Now, the difference between single mode and multi-mode is purely based on that core. It can be just a strand of glass. Okay. Now, if this single strand of glass, if its diameter is what makes a difference, its thickness. If the thickness is higher or bigger, Okay, now that is called multi-mode. If the thickness is very small, then it's called single mode. Now, just to show an example. Okay, so these are the, for example, or I can even show you this. Okay, so this is the core that transmits the light. Okay, so when I say the thickness of this. Okay. Now,
How many cables per, or how many of those wires per cable?
there's so many types. I mean, you can have, it depends on where you're using. Like, if you're connecting two continents, obviously there will be a bulk of cables inside.
Oh,
So it
okay.
just depends.
And each cable is a bit or something like that, or
Each cable is?
does it have any relation with the bits of data, or it's like each?
Oh, yep, obviously. There are so many types of fiber optics, which the minimum ranges from 350 meters. Okay, the length of the fiber optic cable is minimum is 350, maximum is 160 kilometers. One cable can go 160 kilometers.
160 kilometers.
160
One
kilometers.
cable.
One cable, one
Without-
straight
without
cable
repeater.
without repeater.
Wow. So if it's made of glass, if you twist it like this,
You cannot twist it.
Yeah.
It's not that. It's not easy as easy like this.
Oh,
They're
okay.
very tough.
You break.
Yeah, they're very tough. Now it's actually pretty easy to differentiate between these two with respect to the size, but I'm not getting a clear picture here. Okay, so probably this one. All right. So this is the fiber core. Now you see the single mode fiber, the core size is pretty small than the multi-mode fiber. Okay, so that's the difference between single mode and multi-mode physically.
What's inside? Is it the light going like that?
Yeah, that's the light. We'll talk about it.
Oh.
Okay, so two types of fiber, single mode and multi-mode. Now the difference physically is that the core's diameter. Okay. Now the second difference between single mode and multi-mode. Now single mode uses mostly laser as the source of light, whereas the multi-mode uses LED as the source of light. Okay. Now the second difference is, this is a single mode core and this is a multi-mode core. Now, if you are using a LED source as the source to produce light, now when the core's diameter is huge, now few light rays will pass through in a straight line, and there are chances that the light can deviate a bit. Now when it deviates a bit, the next layer which covers or which protects this core is made in such a way that the light will get reflected. So for example, another ray might get reflected like this. Okay. Now because of this factor, the ray which goes through in a straight line may start here and end here probably in 2 milliseconds, for example. Now the ray which takes a deviated path may reach in 2.5 milliseconds. So even though they originate at the same time, they reach with a delay. Since there is a delay, now you cannot use the multi-mode optic fiber for a longer distance, because the more the distance, the more the delay. So for example, from here to here,
On Earth.
it may, the straight path ray may take 4 milliseconds, this may take 5 milliseconds. The more the distance, the delay is getting more. So multi-mode cables are used for shorter distance. So when I said the minimum is 350 meters, now you will not see multi-mode fiber optic cables being used for any connections that are beyond a kilometer. Okay, 350, 550, 650 meters, they use fiber. Okay, within the office, connecting two core switches, you will use the multi-mode fiber optic. Okay, now for longer distance, we use the the single mode, and we use laser, which is more powerful, and the core diameter is so thin that the most of the rays that go through, they will travel in a straight line. Okay, so the laser property and the LED's property are very different. Laser can go at a faster rate to a longer distance, whereas LEDs cannot penetrate to a faster distance, longer distance. Okay, and laser can carry more data. Okay, so that's the basic difference between single mode and multi-mode. Single mode is used for longer distance, multi-mode is used for shorter distance. So if you
8 hours, you said? So laser? 8 hours?
nothing related to hours.
What?
Nothing related to hours. So single mode is used for longer distance communication. Okay, anything like 10 kilometers,
Okay.
50, 60, 40, whatever. So you will see only single mode. You will not see a multi-mode cable being used there. Okay.
Single
Yeah,
mode
but they are
cable.
expensive.
For a single mode cable, if there's a fiber cut and the guys are repairing it, they would have to use that protective mask to avoid the laser contact.
Yes, laser. The thing is, the light cannot be exposed. The jacket that's what we say. This is the core. So the one which protects the core is the outer jacket. Now that outer jacket should be so strong that there should not be any leakage of the light. If there is any leakage, then you lose the data. Okay. But with the fiber optic, there's no question about EMI, electromagnetic interference, because it's only light. All right. So this is about fiber, single mode and multi-mode. Now next is twisted pair. There are two types of twisted pair. These are pretty easy. UTP and STP. Now UTP stands for unshielded twisted pair. STP stands for shielded twisted pair. So as the name says, one type is not protected or shielded, the other type is protected or shielded. Okay. Now, from what we are protecting or from what we are shielding?
EMI.
Again, EMI. Okay. EMI is from which we are protecting cable, but it's very hard, very rare to see a shielded twisted pair cable. It's very rare. Okay, because wherever you see, because most of the time you work in an organization or a company, whatever. Now you will see only a UTP cable, unshielded twisted pair. The reason, unless and until you have a very huge electromagnetic force in that location, you will never go for a shielded twisted pair. Okay, so whatever you see, I think 99.9% it's all UTP. Okay, it's all UTP. All right. So UTP is very, very inexpensive. Okay, they are very cheap. But on the other way, STP, shielded twisted pair, are expensive. They are thick. Now, what is the difference between STP and UTP with respect to physical difference? There's no difference between the type of wires. They are still the same. But to protect the wires, there is an extra shield that will be there, like in an aluminum foil. Okay. Now, if you look at a picture, you see the foils. which we don't see in this cable type. Okay, so there's no extra protection for UTP. For UTP unshielded, we don't have any extra protection, just the outer plastic jacket, and inside that we just see the cables. But in case of STP, along with the outer jacket, you will see some kind of protection from the EMI.
For what you use this one, the shield?
Shielding from the EMI.
For what purpose?
What is it used for?
What is the reason for?
You are using this one, you said, because you got the LED one.
Which technology you use
No, this is for twisted pair. Where is LED coming in?
Oh.
LED comes in fiber optic.
Fiber, yeah.
This is copper. This is coming under twisted pair.
Yeah, I
Twisted pair.
understand. Why there are so many? Why just not use the fiber?
Okay,
It's
fiber was
much better and
okay. When did fiber come and when did twisted pair come?
no, okay, so only because of that, so those cables start.
It's not only that. Fiber is way expensive. When you start running a company and when you want to submit a proposal for wiring, now you will not go and say, okay, let us start using fiber optic everywhere. Okay, it's not going to happen because cost is another factor that you have to see. So you will not see anywhere fiber optic cable connecting two switches. Okay, only the core switches we will be using a fiber optic, because it's not about using a fiber optic, it's about the device, whether the device supports fiber optic or not. Switches and routers will not support fiber optic in all the interfaces. Only couple of interfaces they will support the fiber optic. So
There's no need to-
majority is twisted pair. Okay, 90% it only accepts a twisted pair. In case, that's why I said you will not see an STP, because very rarely we have a surrounding which has a very high powerful EMI. Probably in those scenarios, they may not go for STP, they may go for coaxial, because coaxial is so thick that it again protects from EMI. Okay, so you working on a STP is very rare. You looking at a STP cable is pretty rare. Okay, unless and until it's a rough industrial environment. But most of the cabling that are done within an organization is all about UTP. Okay, the simple, inexpensive cable. Okay, RJ45. Okay, so all you need to know is, be it any Ethernet cable, the maximum distance is 100 meters. Okay, there is an exception though, but that's not being covered here. Okay, so there is an exception, only one cable type which will go for 55 meters. All right, the last thing that we need to talk about before the break is something called plenum and non-plenum. Okay, what is the standard way of cabling in an organization? The same body which we saw, TIA, EIA, who defines how the cable should be colored. Now they are the ones who came up with the standard saying that, okay, if you are running an office or an organization, now this is how the cabling should be structured. Obviously, these days when you have, it can be any type of a business, still you need network devices. You need to have connectivity to the outside world. So for that, and you will have a lot of computers. So if you have computers and if you need internet connection, by default, you need to have switches, routers, modem. Without this, a PC cannot go to the internet. So since you have different types of devices, you will not throw these switches and routers and modems just like wherever you have space. You need to have a dedicated room for that, and that needs to be secured physically and through software, so that anyone except IT can enter. Okay, so that is given. That room is now called as a telecommunication room by standard. Okay, by standard we call it as a telecommunication room, where you will see racks like that, switches, routers, or all the other devices. Now that is the room from where you provide connectivity to all your devices inside your office, and you will have an internet connection from your service provider. Now the service provider's line will first drop into your office into the telecommunication room. Okay, and from there you provide communications to all other parts of your company. So, for example, in this office, that's called as a telecommunication room, and these are called work areas. Okay, so for example, there are 10 people working here, there are 10 PCs. Now I need to make sure I drop down at least 10, minimum 10 cables to this room. Now how I'm dropping it, it's on my choice. Okay, so I can have, if it is like a very posh interior designing company, when people come in, they don't want to see anything ugly. So what I will do, I will never show any cable outside. Okay, so I will just use a posh sockets so that the cable just comes out to a minimum length. Okay, now in other scenarios I may not do the same. I can just drop the cable down. Okay, so I can just the two cables dropping down, so I can just drop down because no one is going to question me, okay, it's looking ugly. Okay, so that is the example of a horizontal cabling. So I take the cable from the telecommunication room, I run it over the ceiling, and I drop it down in the work area. Now that is a standard. You have to take the cable from the telecommunication room, run horizontally over the ceiling. Running the cable over the ceiling is the standard, not on the floor. You can run on the floor when you don't have any choice. Yes, but you have to take some precautionary methods when you are running the cable on the floor. Okay, because you need to have cable runners. It serves two purposes. One, people don't trip and fall down if you're not using a cable runner. The second thing, when people stamp on the cable is getting damaged. So in order to protect both, we use cable runners so that we don't get tripped down, cable is being protected. Okay, something like this, the black ones. Okay, so you got to stick that, and it should be firm on the table or on the floor. Some people put carpet over that if it is going to be a fixed one, but majority the cable should run over the ceiling. Now this is a false ceiling. Okay, this is a false ceiling, and there is a gap between this false ceiling and the actual ceiling. Now the term that is given to that space between the false ceiling and the actual ceiling is called the plenum. Okay, and the cable type, which is called plenum cable, gets its name from there. Okay, since the cables have to be run in that space, we call it as a plenum cable. Now the thing is, majority of the offices are structured in such a way. Now what about the airflow? You having a separate, you will have a separate air inflow and an outflow. Okay, most of the time we have an inflow, but sometimes we will not have a separate outflow. Air is just going to gush around. Now that is very less. The scenario of seeing that nowadays we have separate inflow and separate outflow. Now when you're running a cable, if there is a fire accident, okay, and when there is a fire accident, this cable is going to get burnt. Now if you are using a very standard cable, obviously when it gets burnt, it will produce toxic fumes. Now the question is whether the toxic fumes has a proper way to go out. If it doesn't have a proper way to go out, it's going to come inside. Okay, now if you are having a structure like that where the outflow is not proper, now you have to use a plenum rated cable, which means those cables, when there is a fire accident, will just melt off without producing any toxic fumes. Okay, they are expensive. If you ask me, everyone uses it? No. Okay, because again they see a cost factor. Probably government buildings will be using it. I don't see anyone coming and testing those cables, whether are you using a plenum rated cable or not. But as per the standard, yes, you need to use a plenum rated cable. They are expensive, but they protect you from health hazards. Okay, so that is plenum. It's going to look exactly like this. The only thing is the material, outer jacket, right? So that will be made of a different material that will also look blue in color. But they are thick. But when you look at physically, it will be the same, more thicker. But when you buy, you have to go and tell them, okay, I need a plenum cable. But when you look at it, it will look the same. It's not something different. Probably it will be written plenum. That's it. All right. So that is cleanup. The last is coaxial. It's nothing much to learn about coaxial. Mainly used for WAN, wide area network. What is wide area network? Anyway, we'll be learning about wide area network after the break. We all know what is a local area network, right? So when you want to connect two local area networks, then you need to go broader than that. That is called wide area network. Okay. So typical example is your home router. Okay. So if you want to connect that to an ISP, you use a coaxial cable. So that is used for, again, WAN connection and for cable connections. Okay. One single cable can carry multiple channels. If you have 60 channels at home, you don't have 60 different cables. It's all coming through one single coaxial. Okay. So that's why we have the term broadband and baseband. What is Ethernet called? The 10 Mbps. I think we studied this before.
No. You said we
10
don't
base
learn
T. We didn't learn 10 base T. 10 stands for 10 Mbps. Base stands for baseband. And T stands for twisted pair. So this baseband means it can carry signals which are having one particular frequency. They cannot carry multiple different signals. Okay, so that's why these are used only for network purposes. This is nothing but the RJ, twisted pair. Now you will not see RJ used in cable connections because they are not broadband, but they are baseband. But coaxial cables are broadband. They have the tendency to carry multiple signals with different frequencies. That's why you get different types of channels at your home, because every channel is different frequency and it can carry any type of frequency or any number of frequencies, and you can just change your channel number, you get the other channel immediately. Okay, so 10, if you see 10, then it's 10 Mbps. If you see 100, it's 100 Mbps. If you see 1000 base T, it's again 1 gig. Nowadays for fiber they say 10 base and not 10, 100 base F, okay, or 1000 base F. Okay, but you will not see that in the exam. It's a network plus thing. Okay, so that's the difference between coaxial and the twisted pair. Coaxial is broadband, whereas the twisted pair is a baseband. Okay. Again, these days we use coaxial for we don't use the shielded twisted pair. Wherever you have to use shielded twisted pair, we go for coaxial because they serve a better purpose than the STP. Okay, so it's thick. Coaxial cables are thick. We cannot bend just like this. How we bend a unshielded twisted pair like this, we cannot bend easily a coaxial. Okay, because it's very protected. In the core, copper wire is very, very protected. Yeah, so that's all about the cable types. We will take a break, a 10-minute break, and the most important part of your second chapter is going to start from the characteristics of TCP/IP. Okay, that's where you get a lot of questions from. You get about 3 questions probably from what we have discussed. Okay, but more questions will follow from the later part. All right. So we are going to learn about a very important TCP/IP. Okay. Now, the whole networking. Okay, so networking means interconnection of devices that we all know. Connecting 2 devices so that they can transfer data, and we can do something with that with the help of transferring the data. Now, in order to make the data to be sent from one device to the other, there's something in the background that should happen, and that's huge. who takes care of that? Obviously, even for basic wiring, we have a standard. So this is something way bigger than that. Okay, so there is a standard, a lot of standards, but there is something called apparent technology. Okay, and that is called the TCP/IP. Okay, we call it as the TCP/IP suite. Okay. Now we are not going to study a lot about them, okay, because A+ is not a course for that, but we are just going to touch base on few topics, okay. Now, we all know what is an IP address. So, if I ask you to define, okay, there's no standard definition for IP address. I mean, if I ask you what is an IP address, what can you just say? Remember, what is it used for? Is it really required? What is an IP address? Other than silence.
Identify you on the network.
Identify you on the network, yeah, correct.
Unique identifier, right?
Unique identifier, yes.
Signature of the device.
Signature of the device? Yeah, signature, that's a very different word there. Okay. We don't use, yeah, it's a unique identifier. Okay, it's a unique identifier for a device. Now, we can call IP address in literal terms. We can say a street name. Okay, because we have a lot of things to discuss. Now, IP address is a number given to each and every device which has to be a part of the network. Now, if I have a laptop and if I decide to write a Word document on that laptop, or if I decide to watch a movie which I have already have it in my laptop, now in that case, do I need an IP address? No. So when do I need an IP address? Whenever I have to connect to a network, okay, then I need an identity for myself. If I'm not going to talk with anyone, then I don't need to have any identity. I can be silent, okay. But if I need to talk with someone, then I need to have a name and whatever, okay. So that's IP address. Now, IP address is we also call IP address as logical address. Now, what is the other address we have?
What is your address?
What's the other type of address? One type of address is IP, the second type of is MAC. Now, what's the difference between an IP address and a MAC address? MAC address we call it as physical address. Okay, IP we call it as logical. Now, why is that classification? Why we call one type of address as physical, the other type as logical? Something which is physical, okay, for example the MAC address, we call it as physical because they don't change. If I bring my laptop to the office and if I do ipconfig/all, it will show my MAC address. If I take the laptop to my home and if I execute the same command, I will see the same MAC address, because MAC address comes hard-coded with my NIC card and it doesn't change unless I replace my NIC card. If I replace my network interface card, my MAC address changes, but we don't do that all. So that's why it's called as physical address. Now, coming to IP address, it's called logical. Reason? Same example. If I bring my laptop to Sysnet and if I connect to the wireless network, I will get probably 192.168.10.10 IP. Okay. Now, if I take the laptop to my home, now I may get 192.168 1.10 IP. 10.10 here, 1.10 there. IP address changes as per your network. That's why they are called logical. Today you may have a different IP, tomorrow you may have a very different IP. Okay, so that's why it's called logical. The MAC addresses are fixed. That's why they're called physical IP. Do we need both the IPs? I mean, do we need both the addresses for communication? Yeah. What happens if you don't have one? Communication doesn't happen. Okay? It doesn't happen. Even if you don't have one, it doesn't happen. Now, unfortunately, I don't know how A plus is structured. Now A plus doesn't have OSI layers in their blueprint. Now that's weird because without touching on OSI, learning about networking is tough, but that's how A plus goes. Now the reason why OSI model, there's a model called OSI, which is the most basic thing that we learn in networking. Okay. Now, why is that important? Because that says where exactly each device is come into the picture. Okay, we know that, okay, if you get into an organization, you will see PCs, you will see routers, you will see hubs, you will see switches, but what role do they play? Now that is explained in OSI layer. Okay, so if you get a chance, go and read it, OSI layers. Okay, now since we are not going to discuss on that, I'm just going to talk about a couple of devices. Now, before touching base on TCP/IP, I just want to give a brief information. Now, all the physical cables, okay, all the physical cables, the connectivity is called layer 1. Okay, layer 1 is called physical layer. That's it. You don't have to know more than that. Now, layer 2 is called data link layer. Now, layer 2 is where you see the switches, like that, the one which is making a noise. Okay, so that is a layer 2 device. Switches in general are considered to be a layer 2 device. Now, that is where MAC addresses are. Okay, that is where MAC addresses are. Now, switches are the devices used to do what? What is the purpose of having a switch in an organization? Anywhere. Switches, consider this as a switch. The basic purpose of a switch or end devices. It can be PCs, printers, whatever. Okay, so you connect all end devices here, and we are the end users. Sorry.
You connect on them on what's the purpose of the switch.
Okay, so what happens if you do something like this? You are now a part of a network. Say, for example, you connect your PC, and your friend connects his PC to port number 20. This is port number 1. Now, what happens by connecting these two PCs to the switch? Now you can establish a connectivity to that PC. You can send information. If switch is not there, you are an individual PC, he is an individual PC. Okay, and if you ask me, okay, can we have communication? Yes, without a switch, you can just directly connect a cable, you can transfer the files. But what happens if you want to be part of a network which has more than one user? You need a switch. So that can be 20 users, 40 users, 100 users, it doesn't matter. Okay, so we can connect only to a switch. Always understand, we don't connect to a router.
We don't.
We don't.
The switch connect.
Switches in turn connects to the router. We as end users, when I say we, end users who use end devices, we don't directly connect to a router because the purpose of a router in a network is different. Routers are manufactured or designed or bought into the network for a different purpose. No, he didn't pick it up. Voicemail. So I said I will give a call
Question, Sandra, for the switches, is only physical connection? Can you connect wirelessly to the switch as well? Or
No.
just physical?
No.
Just with the
Wired. Okay, so this is enterprise. In enterprise level, we don't talk about wireless switches, wireless routers. We don't have anything as such. Okay. In general, at home we say wireless router. Now that is different from what you use in enterprise. That's called as a SOHO. So this is the one which we all have at home. Now that's the Linksys SOHO router. SOHO, SOHO. SOHO, which stands for small office, home office. Okay, at home, it's one of the best devices to be used for the internet connection. if you're having a very small startup company and there are only like 5 employees, now you don't have, you cannot go and spend thousands of dollars on these enterprise devices like switches and routers. Okay, so this is good for such an environment. Okay, 5 users, 10 users maximum.
This
Okay.
one has switch and has router working together.
Okay, this has a lot of features inside. Switch, routing, security, which is firewall, NAT, everything is there inside. But everything is basic. Okay, we cannot use that in the enterprise level.
Now, at home, I can connect one computer to the other, right? My laptop to another laptop.
Yeah. So laptop, you have the Ethernet cable, right? So you connect this port to your laptop. You connect another laptop to this port. Yeah.
Oh.
Yeah,
And you can
but-
establish network folder and that's it.
Yeah.
But yeah, I have from the basement connected to the desktop, and then I have my laptop wireless. But it's called modem. So modem is a switch as well.
All right. So you're terming this as a modem.
It's a CGM2 or something. The one that runs is key.
Okay. So basically, how it works. Now this router has 4 LO ports.
Right.
These are LAN ports.
LAN, yeah.
This is a WAN port, the blue. Okay, this is one which connects to your internet service provider. Now, this has the capability of providing wireless service.
Okay.
So, a number of users can connect through wireless. If you want to connect through wired, so probably you may have a printer which is not wireless. So and you may have a PC which is not wireless. So you can connect those devices to these ports. Now, all the wireless devices and all the wired devices that you have connected to this, they are all part of one local area network, one LAN. Now you all can communicate within yourself. If you have a folder to share, now everyone within that network can see that. You all become a part of a network. Now you cannot establish, you cannot configure multiple networks here because this is a basic device. One network, that's it. It can give out IP address, it can secure your network to an extent, it can do switching, it can do routing, it can do everything but to a very limited extent. Okay, so that's why it's limited for home and a very, very small office. Max not more than 10 users. That's good. Anything more than that, you need to go for enterprise devices. Okay. So, but the operation is going to be the same. The magnitude of the features are different from this product and that product. Okay. So that usually has 24 ports.
24.
How many ports this has? Just 4 ports. Okay. So that itself is a big difference. And the hardware, what this has and that has is very, very, very different. That is more powerful than this one. Okay. So this is the role of a switch. The role of a switch is to connect all end users. Okay. Now these cables are layer 1. This switch is a layer 2 device. Now switches will in turn connect to a router. And this is a layer 3 device. Okay.
How many layers do we have?
7.
7 layers?
Yeah. But we are going to learn only about 4 today.
So layer 1 you said is cabling, right?
Yeah, cabling. Okay, layer 1 is cabling and you know a device called hub, right? Hub is also a layer 1 device.
What is a hub?
A hub is a repeater. I will tell you. Okay. I have a switch. Okay. I have all users here connected. Now, for some reason, I have a PC here which I cannot move any further towards the switch. The distance between the switch and the PC is 150 meters.
Too long.
Too long. So I will extend the cable.
Oh.
Cool.
It's gonna have a switch then?
Hub is not a switch. Switch is a layer 2 device. Hub is a layer 1 device. Hub is just a repeater. and nothing more than a repeater.
So I can connect
What?
one or two there. I
Sorry?
can connect this guys through a hub.
Sorry, I didn't get it.
I can connect this computer to the other part here.
Now this PC is connected to the switch.
Oh, okay.
Since I cannot extend the Ethernet cable beyond 100 meters,
Oh, I need a hub.
I need a hub repeater. Now the reason is, the signal that is coming through this port,
And
if it is 100 meters up to here, okay, the signal gets weakened. So I need to amplify the signal so that it can go beyond that. So I use a hub.
Right.
Okay, so since we need to have a difference between a switch and a hub, and hub is a very has very limited features. We don't say hub as a layer 2, we say layer 1, which we compare it to a cable.
So layer one is data, you said? Data, no.
Layer 1, the data bits, yes,
Data.
all zeros and ones. The data that you send,
Yeah.
it's all layer 1. Who takes the data? It's the physical cable, right? All your fiber optic, coaxial, twisted pair, they are all coming under layer 1. Alright, so router is a layer 3 device. Now all you need to know is the MAC address comes at layer 2. The MAC address comes at layer 2. And the next is IP address, comes at layer 3. So routers work on IP address, switches work on MAC address. Okay, we have given each device a specific intelligence. Okay, so based on the layer in which they work, their intelligence varies. Now switch is at layer 2 and router is at layer 3, which means router is going to be a bit more powerful or having more intelligence than a switch. Okay, so a router can understand both a MAC address and an IP address, whereas a switch can understand only a MAC address, because its vision or its intelligence is only up to that mark. We have not imposed a lot of intelligence to the switch. We said, okay, you are built for a specific feature and you just need this to work on that. Now we said, okay, router, you have been designed to do something bigger. I give you more features. Okay, both IP address and MAC address you can understand and you can work accordingly.
So switch only MAC.
Switch only MAC. At A+ level, when I say switch, it's a traditional layer 2 switch. Okay, because we have something more than that these days.
And what are those errors inside the switch?
What are those? Okay, that's the representation of a switch in networking. This is how, when anyone draws, this is how just diagrammatic representation of this. Okay, this is a router, this is a switch.
So it's a square.
Yeah,
with
if it is a hub, we say this is a hub. Just a pictorial representation of devices.
So router is IP and MAC?
IP, I will not say IP and MAC. Router is both, capable of both understanding MAC address and IP address. But we say router is a layer 3 device. So mainly it's IP.
So if they can understand, I can connect a computer directly to a router. Can I?
You can connect, but we don't
Technically,
run.
yeah, you know, use for
We
that,
never.
but technically, you could.
Yeah, that's what I said. When you connect a PC to a router, you use they are not similar device, but we consider them as a similar device. And you go for a cross.
Oh, okay.
Right? But you will never see anyone connecting a PC to a router. You will never ever see that.
No, I mean just for testing, making sure that the.
Yeah.
I don't know.
You
the switch is
you
not-
can connect.
You can.
Yeah. Okay, so layer 3, layer 2, layer 1. Now the last one is layer 4. That's where you have the. This is called the network layer. This is called the data link layer. This is called the physical layer, and this is called the transport layer. You don't have to remember these layers because that is not a part of your A+, but you need to remember the layer 4. You have, say, firewalls. Okay, and this is where you have the TCP and UDP. At layer 2, we have MAC address. At layer 3, we have IP address. And layer 4, we have ports. TCP, UDP. Okay. So now you get a picture why, in general, we say TCP IP suite. So this is the major thing. TCP and IP are the major in networking. Everything comes under TCP IP. Okay. Now you may have a question. Okay, what are these ports in layer 4? Now ports are nothing but I would say you have a laptop and you have opened a browser. Now one of the browser you have opened to one of the tab, I would say, to Gmail. Okay, for accessing your Gmail. The second, you are using it for YouTube videos. Okay. Now the laptop is just one, so your IP address is going to be the same for both these websites, Gmail and YouTube. The source IP is going to be the same. Source MAC is also going to be the same. Now how can you differentiate when your laptop receives some packets from the switch? It receives 10 packets for your Gmail and it receives 10 packets for your YouTube. Now how can your laptop identify, okay, these 10 packets are for Gmail and these 10 packets are for your YouTube? One thing is ports. Your IP address is same, your MAC address is same, so there should be another level where it differentiates. Now that's where port comes in. Now ports are nothing but logical numbers given to each and every application. If you're doing something with respect to email, email has its own port numbers. If you're watching a YouTube video, now that has a different port number. If you're using for HTTP, like in browsing, the browser itself has a port number. So if I say, for example, a street, if you consider a street name as an IP address, okay, now each house inside in that street is a port.
So that means
Okay, so consider this as a street.
I apologize, can you repeat that one more time? A port is a logical address where your application.
Logical, it's not, port is not, port is a number. It's not an address, okay? It's not an address. Port number are logical numbers given for each and every application. Okay, now consider this as a street. Okay, now the street is considered to be an IP address. Okay, now I have 3 homes here. Now there is anything for your PC is given to your IP address. Now in your PC you have opened YouTube, Facebook, Gmail. Now your device has the responsibility to give the packets accordingly to each and every application. Now how can your PC identify, okay, I get 100 packets altogether because I just have one NIC card. All the data is going to come through one NIC card, right? So I receive 100 packets in general. Now it's my duty as a PC to distribute packets to all these applications accordingly. I cannot give packets that are related to Gmail to YouTube. There's no purpose in it. So now these houses are considered to be the port number. Now YouTube will have its own port number. Say for example, port number 21, house number 21. So any packet that is for out of 100, okay, let's say 30 packets are coming with the port number 21. So I give it to YouTube. Next, there are 20 packets with the port number, say 80. I give it to Facebook, and the next 50 packets, say they are coming with port number 110, I give it to Gmail. So port numbers purpose is to identify each and every application that you use.
how many ports in total?
65,536.
Oh, okay.
That's it?
Yeah.
So that means HTTP has.
HTTP, the browsing, the regular browser you use has port number 80.
Yeah.
Now, this is just for a regular browser. Say for example, you want to just go and watch or open a newspaper which doesn't have any authentication. Now you will use HTTP application. You see in the address bar, right? HTTP. Now imagine you're going to do an online banking. Now that is secure,
Yeah.
which means your 16-digit card number and the password which you are trying to authenticate should be secured from others. No one should be able to get those 60 numbers. So now you will not be using HTTP, you will be using HTTP, a secured method that has port number 443.
That's important.
And those
Yeah.
ports are always the same?
Yes, they are standard. So I said there are 65,536 ports. Out of that, 0 to 1,024 ports are known as well-known ports. Okay, these are not well-known ports. These are known as well-known ports because these are standard ports, which we always use for those specific applications. Beyond this, they haven't standardized, so you can use it for other purposes. Okay, but most of the day-to-day ports that you use, applications that you use, will come under this 0 to 1024. Example, 80443. You're watching YouTube videos. Now, YouTube is not live. YouTube have their server. They have someone uploads a video. That video stays there. Whenever you want to watch a video, you click on the link. The video gets downloaded from the server. Now, it's kind of a file transfer. You're requesting for a file. It's FTP, file transfer protocol, and the port number used is 21. Okay. Have you heard about ping? Ping, P-I-N-G, ping. It's used for?
Yeah.
Okay. In chapter 2, okay, that's what I'm going to say. In chapter 2, ping is not for gaming. Ping is used to check whether the other device is active or not in terms of connectivity. Is it up and running? So, for example, I have considered these two PCs. I'm on this PC. Now, I want to know whether this PC is active. I need some file or I need to send something. Okay, so this PC could be turned off. Okay, I'm not sure. Now, before I transmit something, I just want to make sure, okay, that PC is up. Now, I can do a ping to that IP address 10.10.10.10. That's the IP address of this. If I get a positive response, which means this PC is active and I can send. If I don't get any positive response, it means connectivity is not there. I cannot say that PC is turned off, but connectivity is not there in general. Okay, so that is ping. Now, for ping, which is something that we will be using every day, when you start working, uses port number 1. ICMP is a protocol. So there's so many things.
ICMP, what is this?
Internet Control Messaging Protocol. Ping is a utility. Ping is not a protocol. Okay, if anyone thinks that ping is a protocol, no. Ping is not a protocol. Ping is a utility name given. If you do ping, if I do ping from this device to this device, it's giving its work to someone else. Okay, if you say ping to your device, now it's going to say, okay, my user is requesting for a ping. So it is going to turn to the protocol called ICMP saying, okay, I need your help. Because ICMP is a protocol written to do that specific task. Understand one basic thing. In networking, protocol is the biggest thing. Nothing works without a protocol. There are so many thousands of protocols written to do each and every specific task. Whenever you give some instruction, whenever you want to do something in terms of networking, it's only a protocol that is helping you. Some protocol or the other. All these are protocols. This is a protocol, this is a protocol, this is a protocol, this is a protocol. It's every protocol has been written to do some specific task. Based on what your need is, that specific protocol is going to come into the picture. It's going to do that help for you. and those protocols have a number associated with them. Along with the name, they have a number associated with them, and that is called either a protocol number or a port number. Okay. So for example, HTTP is associated always with port number 80. HTTPS is always associated with port number 443. Now you need to know few basic protocol and port numbers, at least 10 to 12, even for your exam, which you use every day. Even though you're not a technical person, you're not doing anything related to networking, even if you are going online to view your email, you probably use 3 to 4 protocols every day. So it's basic that you need to know 10 protocols at least, which is given in the book.
Oh, it's,
Yeah, it's
so
in the
they're
book.
always
Yes.
1024 are always fixed.
Yes. Okay. So that's a brief introduction
So,
of our.
one second, HTTP, right? So YouTube and Gmail, right? We download the packets, you said, or the packets that come through our network card. and
Okay,
come to our computer.
all right. Gmail, YouTube. We don't own that server. That's somewhere in New York, San Francisco.
Right.
YouTube server is in say San Francisco, and Gmail is in say California.
Yeah.
Now, you request, your emails are stored there.
Right.
Okay,
Yeah.
Gmail is free, and it doesn't mean that the emails you have a control over it. Okay, the emails are stored in the server, which is owned by that company, and that is in US.
Right.
Whenever you need to see your emails, you go to that specific site, you enter your username and password, so you go and request the server, okay, show me my emails.
Right.
Okay, so for that you use a different protocol. When you open a browser, you use HTTP, and when you open the Gmail, in specific the mail server, then you are invoking a email protocol like POP3, Post Office Protocol 3, or an older one, IMAP. We don't use IMAP, we use POP3 now. Okay, so IMAP is 143, POP3, IMAP 4 we use 143, and POP is 110.
How about STMP?
STMP? No, SMTP. SMTP.
SMTP.
Simple Mail Transfer Protocol. Now,
We use that.
yes,
25.
25. Yeah,
Yes.
25.
So I have two YouTube.
When you to receive and send emails, you will be using two protocols these days: SMTP and POP3. Two protocols are needed for emails. To browse, you need HTTP or HTTPS. To download a file, you need a FTP protocol.
So yeah. So I have two YouTube videos. You said they use the same port, which is FTP 21. Now, how does the computer know this FTP is for this video and this another layer? Under
That's
that?
a good question. How do my PC know? Now there are always source and destination. When you say MAC address at layer 2, that's a source MAC and a destination MAC. When you say IP address at layer 3, there's a source IP and a destination IP. When you say port numbers in layer 4, there's a source port and a destination port. Always, so if for example you have two browsers open, both for YouTube,
Yeah.
both will have the same destination IP port number.
Yeah.
Okay, but source port number is different. Okay, that's well beyond A+. I don't want to go into that. Okay, so that's the basic. Okay, now based on that, we will learn few more stuff. Now IP address, we say, okay, it's as of now we are going to learn only the version 4. We say IP version 4, which is what we currently use. Okay, and this is written in the form A.B.C.D. That's the form of an IP address. Example, 10.10.10.1, 192.168.10. 100, 172.16.100.200. So these are examples of an IPv4 version 4. So A.B.C.D. Now A is called as an octet, B is in another octet, C is in another octet, D is in another octet. Okay, so there are 4 octets. In general, how many bits are there in IPv4? What is a bit? What is bit?
Binary or like 0, 1.
0 or 1. Okay, that's a bit. 8 bits form what?
1 byte.
8 bytes form okay.
Kilo is not a
Kilo.
thousand.
Kilo.
Yeah, it's 1,000. Kilo is 1,000.
Oh, sorry. 1024. Okay. Now 1024 KB forms
1 megabyte.
forms. This goes on. Now, IPv4 is 32 bits, which means every IP address has 32 combinations of zeros and ones. Every IP address is represented in terms of 32 zeros or 32 ones, a combination of zeros and ones. Okay, and these are the examples. Now, are they binary or decimal?
Decimal.
Decimal.
What?
Binary is 1, 0, 1.
Binary is all about either 1 or 0. Decimal is all about between 0 to 9.
Oh, okay.
Now, any networking device will never understand these decimal numbers. Decimal numbers are there for our understanding. Okay, because humans cannot understand binary numbers. Okay, it's huge. We cannot remember. Now that's why we say IP address like 10.10. or 192.168. But computers or networking devices will not understand in this format. Whenever you give your PC this IP address, for example, it will immediately convert this decimal to binary. Only then it can understand. Okay, so IPv4 understand it's 32 bits. Okay, and I said this is the format for an IPv4, and there are actually 4 octets, A, B, C, D, 4 octets, and each octet is 8 bits. So 8 plus 8 plus 8 plus 8, 32 bits. Each octet. This is 8 bits. This is 8 bits. This is 8 bits, and this is 8 bits. 8 bits, 8 bits, 8 bits, 8 bits. Which means your PC will convert this 172 into
Binary.
8 bits of binary dot binary dot binary dot binary. That's how it's going to say. Okay, so 8, 16, 24, 32. Alright?
Yeah.
Good. So 32 bits, and we have 4 octets. Each octet is 8 bits. Okay. Next, very important thing. Imagine I have an office. Probably I can say I have HR and IT. So these are 2 different departments entirely, right? So physically, how I differentiate HR and IT? I make sure HR sits in a different room, IT people sit in a different room. I make sure with respect to the access, no one gets into the IT room. So these are physical things, okay, which we don't have to bother. Now, if you are a network admin, now you have a responsibility to make sure that HR people do not have access to what IT people have inside their room. Okay, so probably IT people may have a server, IT people may have a printer. I have already given a HR a printer, and they have their own server to have all the information about the employees. Now, IT people don't have any business to access this server, and HR don't have any business to access that server. Now, as a network admin, I have to make sure that these kinds of access are revoked, right? If I don't do anything, everyone can access everything until I make a restriction. Now, how can I make a restriction in terms of networking? Physically, I have restricted. How? I have put them in two different rooms. I have made sure there is a tagging. Okay, so people need to use an access card to get in. So probably I may not allow HR people to get into IT. So that is something different. Now, with respect to network, yeah, HR people can sit here and with even getting into that IT room can still access the server if I don't do anything. So I have to restrict. Now, that is where networking comes into picture. I will say I will put HR in a different network. Okay, I will put HR people in a different network. When I say different network, example 10.10.10.0 network. So that's a network I give for HR. And I will put IT people in a different network called 192.168.10.0 network. So through networking configuration, I make sure HR are different from IT. Now once I have differentiated them in terms of networks, now I have the control. As long as I have both of them in one particular network, I will not have more control. Because in general, people within the same network will have all the access. Let's consider this class. If you have to communicate with that person, now I cannot restrict. I cannot suddenly create a wall, or I cannot block if you are talking to him, I cannot say anything. I cannot block it, right? So you are in the same class, you have all the access. But if I ask you to go and talk to another person who's in a different class, I have some control. I can lock this door. I can lock that door. As long as you are differentiated, you are put in two different things, I have more control, right? So that's the way network works. As long as both HR and IT are the same network, my control over these two departments are less. To have more control, I put both of them in different networks so that I can get more control. Now I can go and say people from 10 network should not access anything in 192 network. That's it. So HR people cannot access anything in IT. Same thing I will do for IT. 192, 168 network people should not do anything with 10 network people. That's it, completely blocked. HR people can communicate within themselves, IT people can communicate within themselves. So how this is achieved? By networks, by creating different networks for different departments.
So both of them, it's one network. So this network is two different networks.
Two different networks. This is a first network, HR network. This is a different network for IT. Two different networks. Two networks in total. They are not the same. They are different networks. Like HR and IT, two different things.
But they exist on one network that you can control. You are on top, and the guy who wants control,
Yes.
this is his network. No?
No, this is all coming under one local area network. This is all coming under one local area network. Okay? So, understand.
So there are no sub-networks.
Sorry?
There are no sub-networks, what you're saying. They are networks.
The networks. What do you mean by sub-networks?
Because what I understand from what he said is
Okay,
that
don't think there is a parent network and from parent network we have something divided. What I'm talking is not like that. It's not like a network is divided into sub-networks. No. It should be a different network.
And even if it's not a physical
These are not
device,
physical. These
Yeah.
are logical IP addresses.
They also have a logical IP address.
These are the logical IP addresses.
Yeah.
See, this is the network name I give. HR is the name of the department.
Yeah.
Every individual person who works in the HR department have their own individual names, right? So like that, when they bring their own laptop, their laptop needs individual IP address. So first laptop will have 10.10.10.1, second laptop will have 10.2, 3.4, something like that.
Yeah.
IT people will have 192.168, 10.1, .2, .3, .4.
Okay.
But this will be the same. 192, I make sure 192.168.10 is same. And I make sure here 10.10.10 is same. Okay? Now, that's where you have to concentrate. This 10.10.10,
Okay.
192.168.10. This portion is called network portion. Because 10.10.10 is considered to be for HR, 192.168.10 is for IT. That's called as network portion. So what I'm trying to say is every IP address has two portions to it. First portion is always called the network portion, which identifies which network is falling under. The second portion is called the host portion. If someone comes to you, okay, you are the network admin, someone comes to you and saying that I have one user who is downloading a lot of bandwidth. Someone is reporting you, say for example your boss, and I want his access to be blocked. So what is your next step? You need to identify who that user is. How can you identify that? Through IP address. And when you try to, or your boss, or you may try to get hold of that user, and first thing what you get is, you get this IP address. You get to know, this is the IP address which is downloading a lot of bandwidth. Now, just with this IP address, what you can come to know, 192.168.10, which means this user is from IT department. Okay, and in IT department there are 100 people. Okay, so you have to have some mechanism to catch hold of that one person. So this 55 is that particular PC. Every PC in IT will have the same 192.168.10, but the last portion will differ. The first PC will have 1, second PC will have 2, 3, 4. The 55th PC will have this IP address. So you know where that 55th PC is, you go and block that user. So this is host. What is meant by host? We are the host. End devices, end users, they are considered to be the host. Okay. If your boss says, okay, there are 3 different users who are downloading a lot, I need 3 users access to be blocked. And when you go and find, okay, you see one user is 192.168.10.55, the other user is probably 10.68, and the other user IP is 10.10.10.23. Now what you will come to know, 2 users are from IT department, 1 user is from the HR department, and you go and specifically block these particular users. So always understand, IP address always has 2 parts. One is called the network portion, the other one is called the host portion. Network portion helps in identifying under which department that user belongs to, and the host portion is going to identify within that department who is this specific user. Okay, so network identifies which department you are coming under out of 10 different departments that you have in your organization. Now, with that, you are inside the organization. Now, when you are inside the organization, there may be 100 people. Now, how to identify that one? Now you need the host portion to identify that one particular person. Okay? So that's why we say IP addresses are unique within a network. Okay? No 2 users will have the same 192.168.10.55. Yeah, only one will have 55. The other one will have 56, 57, 58. This goes on.
And the point zero is coincidence or always?
Okay,
the number?
point zero is nothing but the name given to that network. So how you call general HR department, IT department, sales department, finance department. You give a name to that department, and you say, okay, there are 10 users under that department. In terms of networking, in terms of IP addresses, IP address scheme, for HR net department, HR team or HR department, we give a name associated in terms of numbers. If I say 10.10.10.23, 24 are users, now they all belong to a team called HR team. So that again we map it to a number called 10.10.10.0. Okay, so that is the name given to that department in terms of networking parameters.
But it could take a number 10 or 11.
No, it's always the first number. It's always the first number. That's 0. We don't have a choice.
No choice in this case.
Yeah.
Do you assign those IP addresses to like 0.55?
Yes. Either you can assign it manually. I can get into each PC and I can say you are 25, you are 56, you are 23, or I can do it dynamically through a server, which we will be learning.
But even if it's dynamic, every day won't change.
It will change. That's why we say
Okay.
IP addresses are logic. Today you may be coming early at 8 o'clock to the
okay.
office,
You
so
see.
you will get the first IP. Tomorrow you may be late. You will not get the first IP or same IP. Someone who came early today would have got this IP that you got yesterday.
So if I do IP config every day, it may be different.
Yes.
Oh.
That's why it doesn't matter with the IP address. That's why we call it as a logical IP address, logical address. It keeps changing. And it doesn't matter even if it changes.
Even at home?
Yep. Anywhere, IP address can change. It doesn't have any impact. Alright, clear? Now, we're going to talk about classes of IP. Now this is very important for you, okay? IP address scheme is divided into 5 classes called A, B, C, D, and E. Now before we learn about the classes of IP, you need to understand in IP addressing, the numbers are from, the range of numbers are from 0 to 255. Nowhere you will see a number that is 256 and more than that.
So it's
The number, yeah, 2 to the power of 8 is 256. So that's the reason. You will never see a number that is beyond 256 in networking. 255 is the maximum number that you will see. The IP addresses, what I'm talking about, it will be 0. It can start from 0 and it can go up to a maximum of 255. So all the IP addresses are within this range. Okay. Now, what is important for you with respect to the exam is you need to know. So this whole range of 0 to 255 is now subdivided into 5 different classes. Okay. To make it easier for a network person to design his network. That's it. Nothing much. Okay. So to make it easier for a networking person to design his network, they have divided this 0 to 255, which means 256 numbers, into 5 different classes. And class A range from 1 to 126. Okay, it should start from 0, but it doesn't start with 0. I'll tell you the reason why, but this is something that you have to memorize. If you don't know, if you're not sure as of now, you have to memorize because you will get questions for sure. This is the most basic thing that you will have to learn in networking or IP addressing. Now, class B is from 128 to 191. Class C is 192 to 223.
That's 127.
Yeah, I will explain. Class D is 224 to 239, and class E is 240 to 255, or 254 sometimes. Okay, so what is missed out is 0 and 127, which I will explain. You have to memorize this if you're not sure of it as of now. A is one, because in the exam they may give you an IP address and they will ask you under which class does this IP address comes in. Okay, and you have to make the right choice. Now, based on these numbers, now if I ask you which class this IP address belongs to, how class C?
Class A.
How class A?
Or
Alright, so whenever you
first number.
whenever you are trying to decide which class an IP address belongs to, one thing that you have to understand is we never consider the last 3 octets. We always see
First.
the first octet number. That's it. 10 is between 1 and 126, so this IP address is under class A. 192, C. 221, up to 223. Okay. Most of the time in the exam they ask you 224. This is class D. Okay. So you just look at the first octet and take the ratio of which class it belongs to. Got it? Alright. So 0 doesn't come under any class because this is used for special routing purpose. So we are not supposed to use an IP address that starts with 0. Always understand, starts with. It doesn't mean that the third octet or second octet or fourth octet cannot have 0. They can have 0. But the first octet cannot have 0. So no, if you are a network admin and if you are trying to give IP address to each and every user in your network, make sure no user will get an IP address that starts with 0. It cannot, because that is reserved for a special purpose. Now, coming back to 127, this is very important for your exam. 127 network, which means 127 dot any number, x dot x dot x. Okay. Now that is called as loopback network. Have anyone tried to give this command 127.0.0.1?
Yes.
Why?
Check your lead card is working.
No.
This network 127. Whenever you see the first octet number as 127, now that means it's a loopback network, which means there is an okay. You are a network technician and someone is just raised a ticket. I'm unable to access. Now, how do you try to resolve? The first point of troubleshooting is you have to make sure whether his device is working fine or not. Say for example, this is a brand new device and he says, I just opened it it's an out of box device and I'm not able to access the internet. Now, your first point of suspicion should be on the device itself, rather than thinking, okay, the Google server may be down. No, that's not going to happen. First point is check whether your PC is working or not. So how can you check whether your PC is having a NIC card, right? And that NIC card is going to connect to the switch.
Right.
So how to make sure this NIC card is working fine or not? You can do a ping to this IP, which means this PC is going to check whether this NIC card is properly functioning or not. It will try to send and receive some information to that NIC card. And if you get a positive or successful pings, it means your device is working fine. So issue is beyond your device. So you go to the next point, okay, try to access the switch and see whether this cable is faulty or not, or this port connecting to the switch is faulty or not. But you have made sure through this command your PC is working fine.
What about if you're not connected to the internet through the LAN? It's a desktop, so no wireless or anything. You're not connected. Can you do the thing as well? And it will tell you.
All right. If you are not connected to wireless, if you're not connected to wire anything, still you can do 127 thing. It will work. Yes. It doesn't require you to be connected to a network because you're not checking anything in the network. You're checking your own Ethernet stack. So it doesn't require you to be connected to anything.
What would be an error message if you come back that something's wrong with it?
Request timed out.
Yeah.
For 127.
Yeah. You should always see a successful ping to this IP address.
That's there's a couple of NIC cards, right? Like the LAN and the wireless NIC card. It's only one NIC card.
It depends on which NIC card is enabled.
Oh.
Depends on which NIC card is enabled.
So one laptop will have two NIC cards.
Yes. Every laptop have two NIC cards. One is for wired and one is for wireless. Okay. So always understand that number 127 is called do-back. And these three numbers can be anything. Even if you say 127.200.200.200, it's still the same. 127 is the key number. Okay. So that's why. So since this is already reserved for a special purpose, we don't take it under or consider it under any class. Okay. All right. So 5 different classes. Now there is a reason why I draw through the line. Now class D and class E, we are not supposed to use it.
We are not.
We are not supposed to use it for users. No user will have an IP address beyond 224. Or no devices in the outside world, which is internet, will have an IP address of 224 or more than that. Because they are used for different purpose. They are not supposed to be used. This is called as multicast. These are important for your exam, okay? And this is used for research purpose. 224 to 239 is coming under a multicast network or multicast class. Okay, what is multicast? One to a group. Communication between one to many or one to a group is called multicast. There are 3 types: unicast, multicast, and broadcast. Unicast means one-to-one communication. If you are talking to another device, just one device, it's called as a unicast communication. You are talking with another person, that's it. Now, multicast means one-to-many. If you are chatting with your friend, that comes under unicast. If you are in a Skype group, that's a multicast. You're not talking to everyone who are in Skype, but you are talking to a group in Skype. So that's a multicast. Broadcast is one to all. Okay. So multicast is a special address, and that is this one. And it can be anything between 224 and 239. So in the exam, they will ask you either by giving an IP address in 224.10.10.10 whatever, and ask you what type of IP address is this, or from the choices below choose the multicast IP. So they will give you 10.192.172.255. And that will be a 224. So 224 is a multicast. Okay, so these IP address range from 224 to 255, we don't use it. So we can take it off. Which means we are left with up to 223, A, B, C, for assigning IP addresses to the devices, network devices. Okay?
When you say that the class E is research,
Class E, yeah.
yeah, what is like research? What, like research company, like
No.
military, like something?
Yeah, in special purpose, they just say it. We never know, they don't expose who's using that, for what purpose it is being used. They just say, you cannot use it. That's it.
IBI, FBI,
So probably people who,
CIA and stuff.
no one knows who
Like,
uses it.
That's a good question. I don't know if you guys follow the NSA. You know, what happens if you use those reserves? Can they hack you?
Sorry?
Let's say that you're using those reserved IP addresses.
Mm-hmm.
If they're not,
See, an example. If I am the network admin here in Sysnet, and if I decide, okay, all the users connecting to the Sysnet should get an IP 224 dot or 240 dot, which is not supposed to be given, I can give it. No one will come and arrest me. No one can arrest me if I use 240, which I'm not supposed to use, but even if I use, no one can arrest me as long as I keep that within my office. If I try to use that IP address and go out, then I get arrested. And even before I get arrested, I cannot have access to the internet world because I'm connected to the ISP. And ISP will first analyze what is this guy's IP address. If it is beyond 224, I immediately drop it. ISP will never accept any packet that is beyond 224. It will first look into that, it will drop the packet. So there's no point in using those IP addresses which are not going to help me in accessing the internet. Outside world will never accept. So you can use it within yours. No one is going to question you. But with that IP address, you cannot go anywhere outside. So there's no point in using those IP addresses.
The other thing is, I always see everyone uses 192.168.
Yeah, coming to that.
Is that Toronto or?
No.
Worldwide. It's always 192.
You will learn that now. Okay, but make sure you get these classes. Okay, classes of IPs. Now we talked about network portion and host portion before we talked about the classes. Now they have said there is a default network portion, and so how many of you have heard the word subnet mask?
I've heard it twice.
Wow. You remember that you have it twice. No one?
I heard.
No, when you do a config, you see subnet mask.
Okay, so people who have heard subnet mask, now what is a subnet mask?
They are not here, those people.
255, not here.
Alright, so if I go to my adapter settings, and currently, so you see the cross marks, which means that they are not enabled, but wireless is enabled. So I go to my wireless.
Return Sinan, sorry. Maybe return off. Now it's.
Someone has changed the
It's not
settings.
that- Yeah, it's.
Okay, so now someone asked me last class like how to identify the driver, whether it supports A, B, G, N. So you see here, most of the laptops will have the information here. What does it say? We learned about wireless, right?
BGN.
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 B and G both are working at 2.4 gigahertz, and N is something that will support both. So that's why you see 2.4. I don't have the letter A here. So if it is A, then both 5 and 2.4. Okay. All right. So for someone who has not assigned an IP address to their device as of now, okay. Now where do you go
To assign an IP address?
to assign an IP address manually or statically to your network? Okay, to your device. If someone says, okay, go and assign this IP address to your device.
Why do I need it? Sorry, just.
You need an IP address, right? Without an IP address, you will not be a part of a network,
Okay, so.
right? So if you are sending a parcel to someone, you need to put from whom it is coming. From address you have to put. If you're not going to do it,
I connected the printer between two computers and I need to.
yeah, you need to know. You need to give an identity to that printer so that these users can access
Find
that
it.
printer, find the printer.
Perfect.
All right. So here, at the bottom of your screen, you will see a wireless or a network connector symbol which says, okay, you're connected wirelessly. Or so all you need to do is right-click there, and you will see Open Network and Sharing Center. Okay, so click on that, you will get this page. You go to the Change Adapter Settings. You're here. Okay, now here is where you will see all different types of connections that is possibly available on your laptop or on your device.
The
Okay,
adapters are the NIC or the-
so this is for wireless, and that is a separate NIC card. This is wired. This is a separate NIC card, and this is Bluetooth. Okay, this laptop has a Bluetooth, so that's a different NIC. Okay, so 3 different. Now, as of now, I don't have any Ethernet cable plugged in, so that's why I see a cross mark and it says network cable unplugged. Okay, the moment I connect a cable, it will say network cable plugged. Okay, now if I want to give an IP address to this PC manually, I click on it and go to Properties. And this is what I get: Wi-Fi NIC card properties, and that's where I see what kind of a NIC card it is. Okay, it's a Dell wireless, whatever. Now, one of the fourth option says Internet Protocol version 4, TCP/IP version 4. Okay, so you select that and you go to the properties of that, and this is the proper TCP/IP v4 properties window. So in the general tab, you see there are 2 options: obtain an IP address automatically. Now this is the default setting that you will see, so that your device gets an IP address automatically. You don't have to go and define an IP address. It makes life easier for everyone. Okay, but if someone says, okay, go and define an IP address for yourself statically, now you have to select the second option which says use the following IP address. Okay, now when this option is selected first, you cannot go and type anything here. See, even if I click, nothing happens. That's disabled. But the moment I enable this, now I can go and define an IP address. Okay, so I can give any IP address: 10.10.10.10. Okay, so what is that column called? IP address. Now what is the second column called? Subnet mask. Now if I go here, it even without typing, it says automatically 255.0.0.0. Okay,
Did you click this?
I just clicked here, that's it.
Okay.
Now let me go and delete this and make this as 150. Okay, now if I click here, it says 255.255.0.0. Let me go and change this to 200.
Never sure.
It's very close.
It says 255.255.255.0.
Different class.
Yeah, so that's what I'm going to say here. Every classes of IP address have their own default subnet mask. Now first, before that, what is a subnet mask? I said, if someone gives an IP address, you need to identify which network it belongs to. I just throw an example. 10.10.10.0, 192.168.10.0. I just gave an example of these two. This is HR and this is IT. And I said, okay, I drew a line like this. Now, what made me to draw a line here? Not here or not here. There's no standard that says, okay, you can draw a line only there. You can draw here, you can draw here. That is an example. Now, where you can draw that line to make sure which is coming under network and which is coming under host. Who decides on that? Your subnet mask. How? If your subnet mask is 255.0.0.0, that means wherever you see 255, that's network portion. So that means you draw a line here. If it is 255.255.0.0, then first and second octet is for the network portion. So you draw a line here. Now, if you have 255.255.255.0, then first three octets are for network, last octet is for host. So then now you draw a line here. So these three are under network, this is under host. Got it? So all you need to understand is subnet mask defines which part of your IP address belongs to network portion and which part of your IP address belongs to host portion. That's it. Okay. So this is a default subnet mask. You can go and change it. We will always go and change this subnet mask. Okay. It just throws a default subnet mask, but we will always go and change as per our requirement. So we are not going to discuss more on that because A+ doesn't require that. But all you need to know is we never talk about subnet mask, but we talk a lot about IP address. One thing you need to know is subnet mask is as important as your IP address. Without a subnet mask, you cannot configure any device in the world. Any device, PC, laptop, your mobile, your routers, switches, none of the device will accept an IP if you don't give a subnet mask. It will always throw an error. The error will be provide the subnet mask. Okay, so subnet mask is so important. Alright, so if you decide to give an IP address, you have to give these two parameters mandatory. It's not an option. You have to give both IP and a subnet mask. Okay. In case if I just delete it and try to say okay, you have entered an address that is missing its subnet mask. Please add a subnet mask. That will be the error that you see. Okay. So subnet mask is very, very important, and the purpose of it is to differentiate your network portion from host portion. So that will make sure which network this user is falling under.
I wonder why it would be part of the fields if it's set. It depends on the class of the IP address.
Okay. I'm not going to spend a lot of time. Only one point to say is subnet mask. There is a default subnet mask which is 255.0.0.0 for class A, 255.255.0.0 for class B, 255.255.255.0 for class C. These are default. It doesn't mean that you have to stick to these subnet masks. You go and change your subnet mask as per your requirement. There is something called default, that's it.
Okay.
You will always go and change it. Most of the times you will go and change it, especially these two subnet masks. There is a reason, but we are not going to look into it. Okay. Subnet mask will always be modified as per your requirement. Okay.
So there is another step here, but it's not for A+.
Yeah. A+ is very, very limited.
So CCNA teaches you that as well?
This is the basic thing you will learn.
CCNA?
Yeah. CCNA actually, yeah, you will spend some time here. Yes.
More than network plus.
Oh yes, obviously.
man.
Obviously.
So there's no question about subnet.
No,
A-file.
no, not at all.
just for curiosity, if you put on the IP address the 127 loopback network, whatever, would it give you a subnet mask? There you go. What?
IP address starting with 127 are not valid because they are reserved for loopback addresses. Please specify some other valid value between 1 and 223.
Yeah, they are. Yeah.
Okay. So your PC is smart.
Yeah.
Okay, so
So if we're doing the exam, we can go on the computer and print a couple of numbers so we get the 127.
so clear? Okay, so make sure you get these numbers in mind and the default subnet mask in mind. That's it. Okay. All right. It's 12. We will have a lunch break between 1 to 1:30. So you want to continue, or you need a 5 minute break or something like that? Till 1.
Can we have lunch break a little bit early?
What time? Yeah, that's fine.
12
12:30.
to 1 or 12:30?
12:30.
12:30 to 1, yeah.
Yeah.
Okay,
So we'll have it 12:30 to 1.
That is too late after 1. I have
Okay.
to have lunch on time.
All right. So 12:30 to 1. That's fine.
Yeah, it's coming.
Because it's been long time since I had a class that is 9 to 3. I usually have a 9 to 2. So I was literally confused, like what is the time scheming like I have for 9 to 3. So it's a different for 9 to 2 because we don't have a lunch break for 9 to 2.
Okay. So today we're 9 to 3 or 9 to 2?
9 to 3. Yeah, it's 9 to 3. Until we finish A plus, we are 9 to 3.
I'm sure we were like scheduled 9 to 2, is that right?
Yeah, 9 to 2, 9 to 3, because before it was 9 to 3, and for one batch we had 9 to 2. So
Well, I think the first
see,
or second class.
see,
was 9 to
it's
2.
not about the paper, okay? Even
Okay.
though Canada works on papers, now it's on our flexibility.
Okay.
My availability is 9 to 3. If everyone says okay, not 3, it's only till 2, yeah, it's 2. If everyone says okay, we can extend to 3, then it's 3.
Yeah, we take a lot of breaks, so we can go on to 3.
There's a lot of things to be covered in A plus. That's the reason.
Almost 1 hour break.
Yeah. See, having an issue. Okay. Next is something called CIDR. Most of you might not have heard about this unless you have done your CCNA or Network Plus. Now, classless inter-domain routing. Okay. Now, to put it simple, what are the default subnet masks you have seen until now? 255.0.0.0, 255.255.0.0, 255.255.255.0. These are the 3 default subnet masks that you have seen. Now, these are traditional default. If you go anything beyond this, if you see something that is different from this, now that is called classless inter-domain routing. To make it short, let us take this example of subnet mask 255.255.255.0. Now, if I give you a subnet mask like this and ask you to say something about the subnet mask, what you can say?
Class C.
Good. Class C's default subnet mask. Okay, that's the perfect way to put it. Second, what is I'm expecting one important information. Now, what is the purpose of having a subnet mask? It differentiates network portion from host portion. That's the basic purpose. Now, what the 255 does here, what is the meaning of having 255 here? Now, 255 means the first 3 octets belong to network, and this 0 means it belongs to host. This is the most important point you have to remember. Okay? Now, 3 octets belong to network, 1 octet belongs to host. Now, this is the default subnet mask for class C. Now, we never worry about the number of networks, but we always worry about the number of hosts we get. if someone gives you a subnet mask like this, 255.255.255.0, and ask you how many hosts we can get. Now, how many bits are there in IP address?
36.
32.
32 bits, sorry.
32 bits. Okay, an IP address has 32 bits. This is 8 bits. 8, 8, and 8. Now, how do I get 255? If I draw something like this, a table, and have 8 columns. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, representing these 8 bits. If I have all of them 1, 1, 1, 1.
Combination.
Yes, so it's nothing but 2 to the power of 8. Sorry, 2 to the power of 2 to the power of 8. Which is 256. So 1. This will have the value of 1. This is 2 to the power of 1. This is 2 to the power of 2. 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Sorry, 0. 1, 2, 3, 4, 5, 6, and 2 to the power of 7. Now this will have the value 1. This will have the value 2. This is 3. I mean, this is 4. This is 8. This is 16.
32,
This is 32.
64,
64.
128.
128. If you add everything,
It's 256.
you get 255.
255 million, yeah.
So what I'm trying to say is, each octet is 8 bits, which we are clear. Now, what are the two numbers we have in binary? Either 0 or 1. 0 is the minimum, 1 is the maximum. If we have all the 8 bits as the maximum 1, this is the value that you get, 255. If you have all the 8 bits minimum, which is all 0, what do you get? That's why we say IP address is between 0 and 255. There cannot be a number beyond 255. Okay, so that is between 0 and 255. Now, coming back here, how many host bits you have? 0 is the number of host bits. I mean, which means all the 8 bits are zeros. Here, all the 8 bits are ones. That's why you get 255, 255, 255. Since it's all zeros, you get 0 here. So we draw a line like this. Yes, this is network portion, because network portion will always be represented as 1, and host portion will always be represented as 0. Okay, and coming back to the question, if someone asks, by giving you this subnet mask and how many hosts, now out of 32 bits, how many bits are gone for the network portion?
24.
Right. 24 has been given to the network. Whatever is given to the network, the remaining is for the host. We all agree. Out of 32 total number of bits, we said the first 3 octets is completely for network, which means 24 bits have gone for the network. Remaining is 32 minus 24, 8. So 8 bits of the host. And to answer the question, how many number of hosts will I get? That's the thing. Number of host bits is different from number of hosts alone. Okay, so number of host bit is equal to 8. Number of network bits is equal to 24. Together you get 32. Now, if someone asks you number of hosts is nothing but 2 to the power of 8. 256. So which means if I have an IP address, say for example 10.10.10.0, okay, that's the network. And if I have a subnet mask 255.255.255.0, how many users I can get? You're thinking about 254? Forget about 254. It's not
Or
CCNA.
255,
Class
right?
A, you can.
It's not CCNA, so 256. 0 to 255, right?
0 is the
No,
network.
how many total, in total?
Oh,
For that
256.
256. Okay, we'll keep it as 256. Alright, so with this you get 256 users. Now, you are a mid-level organization. Your total strength of the company is 200, and in which you have an IT department where there are only 20 users. Now, will you go and give the subnet mask?
No.
It's like for 20 people, you're going and buying 256 laptops. Since because you have unlimited resource of money, you don't go and buy 256 laptops, because whatever money you have probably will yield 256 laptops, but you don't go and buy. You just go and buy what is required, probably a few more for future purpose, right? So we always adapt to the requirement. Even in networking, giving an IP address, we have to adapt to the requirement. These are free. You're not paying anyone, but still, even if it is free, you have to be a bit organized. Otherwise, you're going to screw your network. Okay? So, how can we be organized? To be organized, you need to know the requirement. Okay, my company total strength is 200, and out of which IT is only 20 people. Now, if I use this default subnet mask, I'm getting 256 users. I don't need that many. I need to reduce. So what I can do, it's a logical thinking. If I give 24 bits for the network and leave 8 bits for the host, I get 256 users. What happens if I give more bits to the network? I'll get less number of bits for the host, and eventually I will have less number of hosts, right? So now, for example, if I allocate 28 bits, I give 4 more. I give 4 more bits to the network. I make it all 1.
To the host?
To the network.
Oh.
Okay, so up to here it's network now.
Oh.
So how many hosts will I have? Host bits? Just 4. So this will now get reduced to 4, which will now 32. Now, if I just allocate 4 bits for the host, what will I get? 2 to the power of 4 is equal to 16. Probably I'll make it as 7. 27 and 5 here. 2 to the power of 5 is 32. So from 256, I came down to 32. Now I will go and use that new subnet mask to the IT department. Now what will be the subnet mask will look like now? First 8 bits are completely for the network, right? So 255. Second octet is also for the network, 255. Third octet is also for the network, 255. Before we had 0 because we had only 24 bits for the network. Now we have given 27 bits, which means I'm borrowing 3 bits from the last octet. So what does it mean? 128 plus 64 plus 32. 128 plus 64, 192. 192 plus 32 is 224. So this will be 224. So this will be a new subnet mask. So with this subnet mask, you can get 32 users. So I'm shrinking. I may not get the exact required number all the time, but I always try to come up with the nearest number, so that the only purpose is I don't waste any IP address. For 20 users, why should I need a network that gives me 250 IP address when I'm not going to use 230 of it? It's not a good design. Okay, so when I have 20 users, if I have 30 IPs, that's better, because even if my company becomes big and if they recruit 5 more IT department users, I don't have to change anything because I have 5 or 10 in the reserve. I can use that. Okay, so that's the main purpose of a subnet mask. Your subnet mask defines the size of your network. If your subnet mask is 255.255.255.0, the size of your network is 250. Or if your subnet mask is 255.255.224.0, your size of your network is 30. So subnet mask, your IP address remains the same, whatever, 10.10.10.0. But by making change here, your size of your network varies. You alright? So that is the main purpose of a subnet mask. Alright, so that is called CIDR. Now, we have gone out of the traditional or default subnet mask. These are the default subnet masks: 255.0.0.0, 255.255.0.0, and this is the default subnet mask. Anything beyond the default subnet mask is called CIDR, classless inter-domain routing. Okay, or we also give a name called VLSM, variable length subnet mask. The subnet mask length is varied from the traditional 8, 16, and 24. Got it? Now, why we don't use these two? Any idea? I said we will not be using these two subnet masks most of the times. Any idea why? These two subnet masks we will not be using. It's based on what we have discussed.
Too many hosts.
That's the
Too many hosts.
Yeah, this is only for network, right? These are for the host.
For the host, too much.
How many hosts? 8, 16, 24. 2 to the power of 24 is equal to 2 to the power of 4 is 16. That is 2. 16 million IP addresses you get. Will any network, any company have 16 million users? No.
Good question. If they put something like this, it will slow down the network or not?
This one,
Yeah.
it will not slow. The network will just go down in a second. That's it.
No, it will say that
Nothing about slowing down.
homes you have million people.
Nothing about slowing down. This network can never exist.
I just saw a customer, they only have maybe like less than 10. They're using the IP like class A.
No. The thing is, subclass is never equal to subnet mask. That's why I said these subnet masks are default, and we always go and change that subnet mask. You will never see this subnet mask. You will never see this subnet mask.
I saw on their setting is this.
They will use a class A IP address, but the subnet mask what they will use is something like this.
What I see is they're using 255.0.0.0. Then the network is so slow. I was wondering maybe that's the reason.
That's the reason, and the thing
I
is,
know that IT guy, he
The-
doesn't know anything. That's
the
why.
reason why their
Yeah.
network is still working
Yeah.
is because they don't have those many number of users. Imagine them having million users and giving this subnet mask whatever they have given, their network will never come up. Yes, it's a very, very bad subnet mask to be given. Even though there is something like that, 255.0.0.0, no one in right sense will give that subnet mask.
Yeah, but
No
I
point.
thought it was weird. But yeah.
Your PC is not going to say anything. Your PC, as long as you give a valid IP and a subnet mask, it will take it. But no. So don't ever look at a IP address class and just jump on saying that, okay, this is the only subnet mask that can be associated with that class. Always understand they have given these subnet mask as a default. You can always go and change to whatever you need. Subnet mask. You can redefine your subnet mask as per your requirement, because organization ABC may have only 200 employees. Organization XYZ could be like Google, may have 5,000 employees or 10,000 employees. So it differs, right? So the size differs. When the size differs, your subnet mask differs. Okay? So it is up to the network admin to come up with the subnet mask. But you have the freedom to use any subnet mask. It's absolutely in your hands to which subnet mask you choose. There is no rule that says you have to use this.
Logic.
Sorry? Everything is working on logic. Networking is all about logic. You think what is good for your network and you design as well. Okay? Alright, so that's your CIDR. And we discussed about IPv4. Okay, so 26, okay. Alright, so let's take a break before we continue with the IPv6 and other stuff. All right, next we will start with the classification of private and public. Okay, after that we will move on to the IPv6. All right, so we learned about different classes, right? A, B, and C. Now A's range is from 1 to 126. B is from 128 to 191, and C is from 192 to 223. Okay, so these are the range. Now, there is something called public versus private IP addressing, as one pointed out. Why I'm seeing 192, 168 a lot. Now, I said IP address that starts from 1 and up to 223 are valid IPs which can be used. Now, in that there is a classification again. What can be used by you inside an organization or inside a home, and what can be used outside an organization or outside a home. Now, outside means public network, internet. Okay, so we have two different worlds. One is the public world, which is the internet. Outside world we call it as, and the one which is private to us. Now, why do we have this classification? Now, originally when IPv4 was introduced, IPv4 has a limitation of 4 billion IP address, which they initially thought it's huge, 4 billion. Okay, but later on they came to know that this is not going to be enough for a long time. So they came with a short-term fix until a new protocol will be developed. Okay, new version is developed. So the short-term fix is, let's restrict the usage of these IP addresses. Now, long back, okay, even when we started, even before we started using internet, okay, long back, there was no concept of private and public. Okay, so if anyone, that's during the initial stage of internet being that available to the users. Now, every user, say for example, there is an office with the 10 users. Now, if all the 10 users wants to go to the public network, now they all had an IP address. It could be different, 14.25.32.172. Whatever. So they all had a way to go and reach the internet. So accessing the internet was not an issue, but the problem was when every device was given an IP address like that. Now soon they thought we would run out of the IP address. So how to preserve the IP version 4 for a long period of time? So the solution that they came up with is, okay, now if you are inside the organization, try to use a standard numbers, which they call it as private IP addresses. We will come up with some range of IP addresses which we will call it as a private IP, and these are the IPs that you can use within the organization. That's the classification between private and public. Now, private is always something that is private to yourself, which means your organization or your home. Public means anything apart from the private, it's all public. It's a huge list, and that is what you will see in the outside world, internet. So we cannot remember the public IP addresses because it's a huge list. It's easy for us to remember the private IP list, and it is something again that you have to keep it in your mind. You have to memorize. Now, the private IP, so each class have their own private IP address range. Now for class A, the 10 network is completely a private IP. The complete 10 network, the first octet that starts with 10 is considered to be a private IP. Apart from that 10, everything else in class A is considered to be a public, which means from 1 dot whatever till 126 dot, okay, except that 10 network. Now in class B, they said 172.16.0.0 up to 172.31.255.255. Now that one single block is considered to be a private IP from class B. And class C, the whole 192.168 network is a private IP. 192.168.255.255. Now, what this means is, inside home and inside an office, you will see most of the time IP addresses in this range. The reason behind is these three are considered to be private IPs, so that we can save a lot of IPv4 addressing schemes. Anything apart from this, if you see, up to 223 is considered to be a public IP, and that is what will be existing in the outside world. Your Gmail, your Facebook, your Twitter, your LinkedIn, your whatever, YouTube, everything is going to be public. Why public? It's for the public to access. They are called routable IPs. These are non-routable IPs in terms of internet. Okay, so by classifying private and public, we try to preserve a lot of IP address. Imagine how many users at home using internet. Imagine how many users at office using internet. That's billions and billions of users, right? So those many number of IP addresses are preserved. Now, for example, if this is the SysNet in this building, fourth floor, okay, and we use 192.168.1.0 network, okay. Now, just adjacent to the SysNet, we have TCP/IP. Now, if I am the network admin of SysNet, I will not know what is PCP. This 192.168.1.0 is my private network. I'm using a private IP. Now, I do not know what PCPI is using for their own private network. They have their own network admin, and he will be configuring a private IP. I do not know, and I don't want to know. It doesn't matter to me. Same for him. He doesn't have to know about mine. So, since we don't have anything to know between each other's network, he may also use 192.168.1.0. Perfectly fine. Say for example, in that apartment, there are about 100 homes. Now, all the 100 are having internet connection with Bell. Now, everyone having internet router from Bell, which means probably the default router IP is 192.168.1.1. And so everyone are in 192.168.1.1, but each one are different. You cannot access what is in the other home's internet connection. You're not neighbors. I mean, in the sense you're not in the same network, right? So SysNet, this is private with respect to SysNet only. This is private with respect to PCPI only. So a same network address can be reused millions of times in the same time. So if you are getting 192.168.1.10 as an IP address to your PC, imagine the same IP, there are about millions of users at the same time holding that IP address within their own private world, okay, within their own home or within their own office. They're having the same IP.
So it wasn't to be unique?
Unique within your own network, within your own LAN. SysNet, this is my own LAN network, local area network. For PCPI, that is their own LAN local area network. IP address is unique within your network. It doesn't stop there with unique within your own network.
But
Public IP address has to be unique throughout the world. If, for example, if Facebook has an IP, say 155.21.23.20, Now that's unique. No one else can have this IP. This is a public IP. Now no one else, if you are going to start a company, don't expect that you will get this IP because that is for Facebook. Now you have to pay for this IP address. Private IPs address are free. You don't have to pay for anyone. Okay? When we discussed about wireless, we said okay 2.4 and 5 are free, which means anyone can use. But other bands are, you have to pay. If you're starting something, you have to pay for it.
So that's within your local network, yeah, you can have, many people have the same IP address, but your router network, your router IP address, then why can be 1.0 for like those two examples?
Yeah, both for them. This is the network, 192.168.1.0. Here it's 192.168.1.0. Now imagine there is a user here who wants to go online, and there's a user here who wants to go online. Now there is a say Facebook server here. They both want to access this Facebook server.
Yeah. How does it come back?
Okay. Now when the packet leaves here, it will leave with, say his IP is 192.168.1.10, is 192.168.1.10. Both are having the same IP.
Yeah.
Okay. Now the rule is private and public IPs are like oil and water. They don't mix. Which means with the private IP, you cannot go outside. You cannot
So
go
you have
outside.
an external IP.
The moment you go with your private IP, your ISP will drop the packet. It will say, I don't recognize this IP address. ISPs do not recognize 10, 172.16 or 192.198. They do not recognize these IP addresses. So what happens is, the moment you go out of your system, now your IP address 192.168.1 will change to an external public IP.
Okay.
If you are an organization, you have to go and buy one for yourself. And PCPI will have their own public IP, something like this. So the moment you go, your IP, private IP is changed to a public IP. Without changing, you can never ever access internet.
So we have to,
At home, it
organizations
happens.
have to buy that external.
If you are an organization, if you are at home, you don't have to go and buy.
Rogers already.
They already
Well,
provide you, because home users cannot shell out a lot of money. So it's being shared, it's a different thing. So it's being shared. The negative side is you will not have a fixed public IP, which we don't care. As a home user,
Yeah.
all I need is internet connection. I don't mind whether I have the same IP or not.
So
But
that-
for an organization, I need a standard IP, because I host a website. People are using that website. Say for example, Facebook is using this IP for their web server. What happens if this address keep changing?
Yeah.
People will not get an IP. So as an organization, you have to go and buy a public IP. As a home user, you don't go and buy an IP, but you still go out to the internet, buy a public IP.
But doesn't the ISP need to have like a fixed external IP so that they know how much data you're using?
So they keep a track. They keep a track of what you are being utilized. What is your bandwidth? That is ISP's part. As an end user, as a home user, you don't have to worry about what is your external IP. They have their own network flow protocols or softwares to calculate how much you have used.
Is there any way to, just for curiosity, to identify what's my assigned IP?
Your router doesn't allow that. It's not designed properly. Some routers may, but devices like Linksys, they don't. But in enterprise, you will get it. Enterprise routers,
You buy it, right?
yeah, enterprise routers, Cisco routers will let you know what is the external IP that you are being converted to. Okay. So that's why these devices, these Linksys devices, TP-Link devices are cheaper.
Yeah.
This is a little off topic, but is there a way to stop your ISP from seeing you what you're torrenting?
No,
No?
no. You can do a proxy.
Yeah, like VPN proxies, but they will still catch. Because
If they want to, they can.
Because let's say that you're using one of the BitTorrents, and you receive the IP address. And
See, if you are using a IPsec VPN, then no one can decrypt the traffic. only you and the end user can see the traffic. If you're using IPsec VPN or DM VPN, something like that. So which
IPsec VPN is what's the name?
DM VPN, DM, D, the letter D and M. Okay. Now, if you're using these VPNs, now ISP has no way to look into what is going on. All they see is, okay, there is a tunnel going on. Inside the tunnel, they cannot see anything. But regular traffic, everything is seen.
But the you know when you use uTorrent and you see the connections, you see an IP address, like where it's coming from.
Yeah, uTorrent they can easily.
They don't have VPN, right? You can't. They don't provide that.
They can easily see what is going on. uTorrents they can easily see.
Yeah,
what is going on.
there's no way to stop that.
Unless you are having a word with the uTorrent guy and he's going to give his VPN connection to you, then you decrypt your packets, then that's possible, but that's not possible. Okay, so that's the public versus private IPs. Okay, so private is what you see within your home or office, public is what is going to be in the internet. Okay, so this is mainly to say IP address.
Who sells this private thing?
Sorry?
Who sells this?
IANA. IANA.
INAA?
IANA.
IANA.
They actually sell
IANA,
it?
I think it's for North America.
They actually sell it.
Who? They sell not private. No one sells private IP because private IP is free. Public IP.
Oh.
These IPs are sold by no one because it's available for free. Anyone can use this.
Right. Here's
Anything apart from this, like this.
Here's reverse. Private is free and public is not free. It's kind
Yes.
of messed up.
Oh yeah, private is free. Public is not free. Public is something that you need to go and pay and you buy. So I don't know how many of you have accessed sysnet.ca website. So to have that website, for you to access any part of the world, now sysnet.ca website should be a public IP,
Yeah.
right? So we have to go and buy a public IP for that.
Oh, okay. So those are the GoDaddy. GoDaddy, all these people. Yeah. Okay.
For startup companies, if you don't want to shell, if you don't have your own web server, go to GoDaddy, pay $10, $15. Your website is hosted.
And if you want a secure port, you pay more, right?
Sorry?
If you want a HTTPS certificate, then you pay more.
HTTPS certificate, you go for a CA. If you need a certificate, digital certificate for yourself, you go to a certificate authority and you get a certificate and you link that to your website. That is different. Alright, so you need to memorize these numbers. Okay?
A lot of memory.
Yep. This is the starting. You haven't memorized anything else now. Apart from these numbers.
BIOS.
These are the only two. These are the only two numbers you have memorized.
From this subject, but before you said a lot of other numbers.
We have decided to be strong by doing A+, right? So it takes a lot of guts now.
Just because it's new to me, I will remember.
Eventually, once you start working,
Working on
these numbers just gets into your brain. Okay?
Are you really working with these numbers or just
Everyone. If you, as long as you decide to be networking, you will see only these numbers. All right. Next is IPv6.
There's going to be some question for the IPv6?
Probably one or two. Yeah, that's it. Not more than that. One or two. Okay, so IPv6. IPv4 is what we learned, which means IP version 4. Now, as I said, IP version 4, they long back, they thought that, okay, one day this is going to get over, okay? No more IP addresses will be available in that range. So they said, okay, we will start working on a different version so that we will have a lot of IP addresses. And they worked on it. They started working on it from 1993, 1994. They started working on IPv6, but eventually only in 2000, after 2000, we started deploying IPv6. Now IPv6 it's a lot different from IPv4, a lot different. Okay, apart from the factor that this is going to be an IP address for your devices and all of that. That's the only similarity, okay? But a lot of things are different. Now, to compare between IPv4 and IPv6, first thing, IPv4, how many bits? Address is 32 bits. Now, IPv6 is 128 bits. That itself is a huge number. It's a huge number. Okay, 128. Every IP is going to have 128 combinations of zeros and ones. Okay, and the next thing is, let me write a format of IPv6. So 2001. Okay, it's going to take some time. That's one public IP. I mean, that's one IPv6 address. Okay, it's a lot different in terms of the size, also the values that you see inside the address. Now, IPv4, 32 bits, and it's decimal. IPv6, 128 bits, and it's hexadecimal. Which means you will see values from 0 to 9 and alphabets A to F. Just like your MAC address. Your MAC address. How many bits are there in MAC address?
Well, sorry.
How many bits are there in MAC address?
You said 128.
That's IPv6.
IPv6.
I'm asking for the MAC address. The MAC address what you have in your PC.
It's like two, like 6 times that.
48 bits. What is the format of MAC address?
Your A40.
6 times pairs, right? 6 pairs.
This is the format of a MAC address. This is how MAC address is written. If you look into your MAC address, this is how it is. 1, 2, 3, 4, 5, 6.
4 bits per.
How many bits? 1, 2, 3, 4, 5, 6. 48 divided by 6. Each is 4 bits. This is 4 bits, 4 bits, 4 bits, 4 bits. Now similarly, here 4, 4, 4, 4. So 16 bits. This is called as a field. Each field is 16 bits. There are 8 fields in every IPv6. So 8 into 16 gives you 128 bits. Okay. So 0 to 9, A to F, where A is 10, F is 15. Okay, so that's a hexadecimal.
What are the fields? The 4? The group of 4?
In IPv4 we say octets, right? We don't here use the term octet. We use field. So this is a field. 2001 is a field. ABC5 is a field. AB27 is a field. Now there is a reason. I mean, why we have so many different fields, because they overcame the disadvantage what we had in the IPv4. If they would have structured IPv4 in a specific way, we might have not run out of IPv4 at all. Since the structure was not in a hierarchical way, now ultimately we ran out of IPv4. So they didn't make this, they don't want to make the same mistake with IPv6, so they had a different structure. Pretty much like your telephone system. You may have a number 416-555-1234. Now I can have the same number probably in Europe. 416-555-1234. It works because if someone dials that number here, it goes only within North America. right? Because there is a country code associated with it. If I dial just 416-555-1234, the call will not land in Europe, because probably I may have to say +44 before that, so that it goes to UK. If I don't dial any country code, it will just go within the North America. If I am in Europe and dial that number, it will not land in North America. Numbers could be same, but something else differentiates. So that same number can be reused again. Pretty much same here with the IPv6. Okay, that is a structure being followed. They have differentiated. Okay, this is a region. This is an ISP. Every field will say something about that IP address. Okay, currently IPv4. Say for example, Facebook has an IP address 150.20.20.20. Is there any way we can identify? There's no way we can say 150.20.20.20 is Facebook apart from the IANA who provided that IP address. Or say for example, after 2 years, Facebook needs another IP. When they go and get another IP, it will be completely different from what they got. It could be now 210.10.10.10. There's no correlation between the first IP that they received and the second IP they received, because there is no structure that's being followed in IPv4. But in IPv6 there is a structure, because if Facebook is getting an IP like this, now this will define where the Facebook is located geographically, which region, San Francisco, and from whom they got that IP address, who is their service provider, and their company, Facebook. So up to here, everything will be the same. They may have 10 different IP addresses. Now, they will have first 48 bits as the same. Okay, the others will differ. Okay, so that's how it is structured.
MAC address is kind of like that, right? The maker is some
Organizational unique identifier. This will be the same for all the devices coming out of that vendor. If you have any MAC address, you go Google and you can find, just with these numbers, you can find who the vendor is. It will say Intel, Cisco, it will say. This is the only part that will differ. That's called similar, yeah. Okay. So IPv6, 128 bits, represented in hexadecimal format. Okay. What else? Okay. One question that you may see in the exam. Now, since IPv6 is lengthy, now they have come with a way to make it to be shorter. Okay. Now, we have not seen anything like that with respect to IPv4, because IPv4 no one cared about the size. It's pretty small, right? Because 0 to 255 and nothing much to shorten about it. But here, since it's lengthy, now there is a way to actually make it short. Okay. Now, if I have an IP address like this, just for an example. Okay. If I have an IP address like this, now how can I make it short? Rule number 1. Leading zeros can be omitted. Why? If I have a number like 005 and if I write like this, if I ask you a question, okay, is 005 equal to 5? Yes, because leading zeros never have any value associated with it. So if you find any field with some leading zeros, obviously you can take them off, because taking them off doesn't change anything. Okay, so that is rule number 1. Rule number 2. Fields with 0, all zeros, okay, can be replaced by double colon. If a field, if all the 16 bits are zeros, then you can represent that field with a double colon. So you don't have to write 0, 0, 0, 0, 0. Okay? Alright. Now with that information, how can we go and rewrite this IP address? So first field is 2001. I cannot change anything. So I will write as 2001. Now the next field is all zeros. I can use a colon. So that's a double colon, which means there are zeros here. Now next field is also zeros. Now it doesn't mean that I can go and add another double colon, another colon. Okay, so that's it.
Yeah.
Okay.
Only once in a row.
So with this 2001, I have represented this. Then with the double colon, I have represented this. Now next is 1256. I cannot do anything, so I'm writing 1256. I have represented this. Next, 0. I cannot use a double colon because the rule number 3 says double colon can be used only once. Okay. So now what I can do, if I cannot use a double colon, I will go back to rule number 1. I will say leading zeros can be omitted. Here it's 005B. I will remove the 00. I will just say 5B. Okay. Now you can also write this as 2001. And if you want, you can represent this as 0. This as 0, 1256, then a double colon 5B. You can represent these 3 zeros as double colon. Both are correct. Now why the third rule? If the third rule was not there, and if it looked something like this, 2001 double colon 1256 double colon 5B. Okay, if you want to restructure it, this is the first field, this is the last 8th field, right? Now where does this 1256 come in?
Don't know.
You don't know how many zeros, how many fields are there here with zeros. It could be 1, it could be 2, it could be 3. You don't know here. So that's the reason we say double colon can be used only once. So if you look at here, this is the first, this is the last 8. Now you don't know how many zeros are here, but you can restructure. This is 7, this is 6, this is 5th, this is 4th. So 2 and 3 are zeros. Likewise, first 8. You don't know how many zeros are here, but you know 2, 3, this is 4. So 5, 6 and 7 are zeros. Okay. So this is something that you can expect in the exam. They will give you a IP address like that and ask you to choose the right short form of it. There is one thing that you need to make sure apart from this, because 2 choices will look pretty much the same and you may think, okay, what's wrong? The issue is somewhere they might have introduced something like this, H. Okay,
H. That's one H.
yeah.
Oh, there you go.
Because there is something till
F, L.
So it will all be alphabets. Somewhere they will just say H. That's it. So
Because what?
because hexadecimal stops with F, right? F is the maximum. Okay, and they are pretty smart. They will not introduce a character like this within the numbers. They will introduce a character, this letter with a lot of characters, a lot of other letters.
Yeah.
So it's easy to miss it. Alright.
The question, if you are really like give a machine or fix the IP for the IPv4, basically you have to type in the whole. It's pretty tough.
So when you say assigning an IP,
No, I mean set up fixed IP on a computer or machine, whatever.
IPv6 it's tough.
Yeah, I mean you. For instance, there are not too many variables. You have to type everything in. That's tough.
IPv6 is huge. It's huge. Okay, we learned unicast, multicast, broadcast. In IPv6, we don't have anything like broadcast. There's no broadcast.
Sorry, I have one question. If the test is coming like H, but you have to make it shorter, but we don't have any from until F we have the shorter. After maybe, for example, we see H, what you have to
You will
do
not
is
see
what
the
is-
letter H in the question. You will see the letter F, H in the answers, the options. Because a real IP cannot have alphabet beyond F. So you will never see that in the question. You will see in one of the options.
the option.
Yes, only the option.
Okay.
If they give it in the question, then it's wrong.
Yeah,
Unless they
that's
ask
the
whether it's a
question.
valid IP or not. Alright, so a lot of things to be learnt in IPv6, but not in A+.
Where?
I know.
Not in A+. Network Plus deals a little bit more, and yeah, but no other certifications. No certifications deals with
Not
IPv6.
for us, not too many. Not too much.
Not too many, but a little bit more than this.
Yeah,
You will
yeah.
learn about the tunnelings.
It's not being used
Yeah.
right now, right?
It is.
IPv6 is heavily used not by the end users. All your browsing
Yeah.
happens through IPv6 because all over the world, few years back, they have completely moved to IPv6. All root DNS servers are IPv6. All ISPs, root servers, port networks are IPv6. Everyone has, they don't have any choice. They have to move because we don't have any IP address left. We end users we are not impacted by it as of now. Probably it will take, they keep saying, okay, it will be changed, it will be coming, but we don't see it. For us to see the change happening, it will take another 5-10 years probably. But it's already done and people are migrating slowly.
How would that like change from IPv4 to IPv6? Were you changing it?
Okay, there are a lot of migrating tools available called as dual stack, 6 to 4 or 4 to 6 tunneling or NATPT. These are three technologies that they use to go from IPv4 to IPv6, which is a part of Network Plus again. Okay, so that's all you learn here about IPv6. Alright, so have anyone seen just like this? Whenever you give IP config, no one saw an IP that starts with 169?
Yeah.
Yeah.
What does it mean?
Self-ascending.
Say it twice.
This IP address is called APIPA, Automatic Private IP Addressing. Windows. Okay, it's mainly for the Windows device. Now, when do we see this IP? So, basically, your device is supposed to get an IP address automatically. That's what we saw in that configuration. Obtain an IP address automatically, right? Okay, you take your laptop to your home or office, and the setting says obtain an IP address automatically, which means someone has to give the IP address and it will take it automatically. What happens if that someone could not provide you an IP address? You don't get an IP address then. If someone is not giving you, you're not getting an IP address. Now, how to let you as a user know that you're not getting an IP address? You didn't get an IP address. Okay, basically we can say 0.0.0.0, but I said 0 is used for a special purpose, right? So 0 cannot be used there. So for that reason, they came up with a special portion of a network in the classes saying that, okay, if you see 199.254, the first two octets as 192.254, then you have to understand that you did not receive a valid IP address. It means your device do not have a valid IP address. That is an issue. Go and fix that first. If you don't fix it, you will not be able to communicate with anyone else who are in the legitimate networks, or you cannot go internet. 169.254 doesn't mean that you got an IP address. since you did not get an IP address, your Windows operating system is programmed in such a way that it will wait for some time, and by that time, if a valid IP address is not received, it will assign an IP address for itself. And that will be in the range of 169.254. The last two octets can be any number, but the first two octets will be 169.254, and that 169.254 is called APIPA, Automatic Private IP Addressing. This IP is automatically assigned by your operating system to say that you did not get a valid IP address. So with that IP address, you will not be a part of a valid network, and you cannot go to internet. You need to get a valid IP. Okay, so that is APIPA. So this happens when you don't get an IP dynamically and you have not assigned any IP address manually also. Okay. So that's what given in the example, 169.254.228.109. That 228.109 can be anything. Okay.
What did they say? That is this valid, or what did it say?
Sorry?
What would the exam say? What would the question be? Like kind of
Question can easily
identify why so.
Yeah, from the options given below, they could easily ask identify the API address.
Oh.
Yeah. Or if, as a network technician, if you don't see, when you go to IP config and if you see an IP address 169.254.228 or whatever, what does it mean? Okay, so.
Can this APIPA address be given by a voice phone?
Can this address be given by a VoIP phone?
Yeah, the voice over IP phone.
Okay, I didn't get your question.
Because I used to work from home and my company gave me a VoIP phone, so I would plug my VoIP phone to the internet and then plug the computer to the VoIP phone,
Okay.
and I would get something similar to this.
Yeah. So when VoIP phone comes under the end device, which is similar to your PC. If your VoIP phone shows its own IP address as 169, then it means VoIP phone didn't get an IP address, a valid IP address. Now VoIP phone works in two different ways in terms of Cisco. Okay. Now, okay, I really don't want to go now. After the class,
No, I'm good. I don't want
Okay.
to confuse
Yeah.
you.
But one thing for sure, any device, if you see 169.254, there's no other alternate option. It didn't get an IP address.
Okay.
There's no other meaning to it.
Okay.
That's simple. All right. Now, when we talked about when I showed you where to configure an IP address, what are the fields that you saw? First is IP address, where you give your computer an IP address, 192.168.10.100. Okay, that's the first field that you see where you assign an IP address. Now, second field is subnet mask. Say for example, I give 255.255.255.0. Now I said these two fields are mandatory for your PC to be a part of your network. Okay. In order to have an identity for you, you need an IP address, and along with the IP address, you need a subnet mask. Now, if you ask me, is this enough to communicate within the network? Yes. This is all you need to communicate within the same network. Same network, which means if you are all under, if I put you all under a network called A+ class and the other class as CCNA class, I give you this IP address 192.168.10. network, and for CCNA I say 10.10.10 network. Now, just with this configuration, you can communicate with anyone within the A+ class. But don't expect that you can communicate with the person from the CCNA class. You are different from their network. So in order to communicate with them, physically what you do, if I ask you to go and speak with them, you have to open this door, go out, enter into their class, and you have to communicate. That's the only way. Okay. So even in networks, it's like that. If you are communicating within your own network, you don't have to go off anywhere. You can just communicate from the place where you are. Okay? Now, you don't need any extra or additional configuration for that, for communicating within your own network. But if you want to communicate with someone who is not in your network, you need some additional parameters, like going out and getting inside the other room. Now, this door, which is called the exit door for you to go out. Now, in terms of networking, this is called as default gateway. The exit door, so that you can go out of your network, that exit door is called default gateway. It's not mandatory to provide a default gateway. Without default gateway, your PC will accept the IP config. But the problem is you cannot communicate with anyone outside your network. So you need to specify who is your default network. Now, who is the actual default? Now, the diagram what we saw in the morning, say for example, there is a PC here. This is a layer 1 we saw, this is layer 2, and this is connected to a router. Now, this point where you connect to the router will have an IP address. That is the default gateway. So this is, say for example, IT. And I have a PC here. And this could be HR. Now, if an IT guy wants to communicate with the HR, now how should the traffic flow? It has to go through the switch to the router, and it has to go here. Yeah, but if you want to communicate with the user here, you don't need to go here because your switch can deliver the packet here. But if you want to go here, it has to go through the router. So that's why routers are important for communication between two different networks. You see routers only when you have more than one network. For, we say, inter-network communication. Okay, for inter-network communication or communication between two different networks, you need a layer 3 device. And router is a layer 3 device. And the IP address you have configured on that router is called as the default gateway. So you need to have that IP address here. So that's the IP address here, 192.168.10.1. So IP address here, so you go out through that, so similar to that door.
So the router IP or?
Not the router's IP, it's the router's interface IP for the IT network, IT department. Because this interface, again, will have that is the default gateway for HR people. If they want to communicate with IT, then again, they have to go through their default gateway. So default gateway is very important for communication between two networks. So if someone says, okay, I'm able to ping anyone within my network, but I cannot go online, first thing to suspect is whether do they have the default gateway address configured. If yes, make sure the IP address configured is the right IP, because sometimes a wrong IP address also could be configured. Okay, so these are two things that needs to be checked. But if a person says, okay, I'm not able to communicate within my own network, if you try to troubleshoot a default gateway, people are going to think you are not good. Simple as that. Okay? Because if he is going to say, okay, I cannot communicate with that person, and if a person is going and fixing this door, it's not going to make sense. Right? So similar to that. Okay, so this is the exit door for you to go to a different department, even to go out of the building. Okay, you don't jump just like that, right? You still take the same door. So if the internet is here, you still take the same default gateway. You go like this. and HR still takes the same default gateway and goes like this. Only one default gateway per user. Okay.
So that I would have a default gateway, and someone inside the room will have a different default gateway? No, the same.
Everyone
Okay.
in this IT will have the same default gateway
Oh, per user or per network?
per network.
Yeah.
But per user, you can configure only one default gateway.
Which is probably the same also.
But there are some advanced configuration settings where you can have two default gateways. But again, that's not it. It's there in the advanced configuration. You can have two. One fails, the other one can pick it up.
Is that usually common that you have within a company HR in one network and
It has to be
always
100%. Not even 99.9%. It has to be.
Why does it have to be?
Otherwise,
Okay,
IT will
if you
give
don't have like that,
access.
if you don't have two different departments, two different networks, you may have different departments, but if you have not segregated with networks, then everyone are having same access. What is the security you have within your network? If someone says tomorrow, okay, my files related to my company's finance has been stolen, now from where you can go and identify who stole it? If you have imposed some kind of restriction, then you can be pretty sure, okay, others don't have access. Now it could have happened within the department itself, or someone has hacked. Now if you not imposed any restrictions, from where you can go and find? Like for example, if you have left your home door opened, and if you see, okay, someone has stolen something, now from where you can identify? Anyone can come and steal it. But if you have it closed with the passcode, now you can think, okay, someone should have known that passcode. Now you can go and identify, okay, who all other than me knows the code to get into my home, right? If you leave it open for everyone, no security.
But are those like share folders and stuff like that?
Shared folders?
Yeah.
Okay. Now shared folders is, if you get into a company, shared folders is not for everyone.
No.
Shared folders probably within the same network,
Yes. Yeah.
department,
Yeah.
in some case probably within 2 or 3 networks.
Yeah.
Okay, that's what is shared something. Now that is coming under system side. Okay, that is coming under system side of configuration, Active Directory. You get into a Windows server, you have groups, and you make sure which group can have this folder accessible. That is different. With respect to network, you need to have a control over what others can do. When you have given a printer to HR department and you have given a printer to the IT department, now why should they access someone else's printer when they have their own? Now printer is something common, okay, that's fine. But servers are very, very important. Okay. Now if someone else is going and accessing another server, department server, first, he doesn't have anything to do with that server. Second, he's making that server to be busy, because this server has to respond to him, who's from the other department, rather than the person who's in the same department. Availability, a lot of factors. But first and foremost is security. Security will be compromised. Security is compromised, you lose your job. That's the next thing to happen. Okay, that's for sure. Okay, so you need to have different departments in different networks. Number one, because there are audits. There are audits for all the companies, security audits. And if you go and tell them that, okay, I have 10 departments, everyone are coolly working on 10.10.10 network, good luck there. Okay, so it doesn't work like that. It has to be in different networks. Since you're not learning about a lot of other stuff like access control list and something like that, so you're not getting an overall picture of different networks. Okay, so that's the thing. That's the reason. If you learn about access control list, then you will understand. Because by differentiating different networks, I can say, okay, IT can access HR's printer, but IT cannot access HR's fax machine. Now IT cannot access HR's server. I can say specific things. What IT can do with others. Vice president of the company can access everything, but everyone cannot access vice president. I can write rules accordingly. Okay, I get granular control over my network.
From my computer, is there any command that I can say, okay, I'm in this network?
ipconfig.
Oh, there you told me too.
ipconfig will say you the IP address, and to see what is the network you are in, you need to have that both IP address and the subnet mask. So I'll show you. All right. Next is DHCP. What is DHCP?
What?
DHCP. Dynamic
Host.
host
Protocol.
configuration or configuration protocol. Now, what does that name say? Dynamically, you are trying to configure something for the host. That's what the name says. Dynamic host configuration protocol. So dynamically, which means automatically, you are configuring something for the host. Now that something is nothing but IP address settings. Now we saw the option, obtain an IP address automatically. That is for the host. Now there should be someone who can give it automatically. Okay, so that server. You have a PC connected to a switch. Okay, PC is bigger than switch. Now you can have a DHCP server here. Now it is here where you configure all the IP address 192.168.10.2
Not the router.
up to 192.168.10.255. Okay, so this is called as a pool. Now,
Yeah.
if I connect an PC here, the PC will get an IP address automatically from the pool 192.168.10.2. After that, if I connect another PC, it will get 192.168.10.3. So this DHCP server is going to release one IP after the other for all the clients that are requesting an IP address. So these devices are getting it automatically. So to get it automatically, they have to send a request first to the DHCP server. When you plug in a PC, it will send a request to the DHCP server asking, okay, give me an IP address. Now server will then look into the available addresses in the pool and give one IP address to those devices. Okay, so that server is called a DHCP server, and the server works on a protocol called DHCP, Dynamic Host Configuration Protocol. Now, there is no specific device that is called as a DHCP server. Whichever device you can run DHCP protocol is called as a DHCP server. Cisco routers and switches give you the ability to run that protocol. So routers and switches can also be called as DHCP server. But in general, in a mid-size to a larger enterprise, you will use Windows servers. Windows 2013, Windows 2008 servers, where they have a DHCP service enabled. So that is called as a DHCP server. Okay. But DHCP is a protocol that is responsible for giving out IP addresses automatically. And the port numbers used for this is 68. 67 and 68, but in general we say 68. I said every protocol has a port number.
DHCP is a
68. Yes. Yeah, DHCP. Now, why did I come here? Yeah. It's too small.
Oh, where was that? I always get it like this. No, where you can do that?
Run CMD.
Yeah, I know, but no.
Properties.
Properties.
The window, yeah.
Change the properties. All right, you can even change the color if you want.
Yeah.
Okay, so if you give IP config, Alright, so now since I have both my wired and wireless connections enabled, I have two IP addresses. So Ethernet, which means wired. So this is the IP address I have, 192.168.1.100. Subnet mask is 255.255.255.0 and the gateway is 192.168.1.1. This is wireless. And this is the IP address, subnet mask, and the default gateway. Okay, so if you want to know which network you belong to, see the IP address, see the subnet mask. So which means 255.255.255. These are network, right?
Yeah.
So this is the network portion. This is the network you belong to. 192.168.1 is the network, and all the users will be having a unique host ID. Okay, so if any one of you are connected to wireless, you will all see this number as constant, 192.168.0. Okay, this number will be constant.
Wireless, right?
Yeah, wireless. If
So
your
your
smartphones, your laptops will all have the IP address 192.168.0, but no one will have 44 because I have got that IP address. So you will all have different IP address, 42, 43, or
Because of the mask, this is what say that you are.
yes. Because of this mask, it says the first three octets has to be same.
Fix the other one for.
This is for the host.
vault.
Yeah, this will be different.
This is the only one.
I'm the only user who can have 44. Okay, so this is a typical example of an IPv6.
Or percent?
Percentage is different. Don't forget about percentage. But that's forget. You don't have to. Then I have to explain what is link local. Okay, so to understand which network you are in, I have to go there.
The default gateway always ends with number one.
Best practice.
Yeah.
It's not a rule, it's a best practice. We always try to give the first valid IP as a default gateway. There are some who give the last IP, but I don't feel comfortable giving a last IP or any other IP other than the first IP. It's a globally used technique. First IP is always default gateway. It's make life easier.
So this is, you have statically assigned those IP addresses?
Okay, this I have assigned. This is dynamic. Wireless is dynamic, and this is static. That is static. I have assigned it static because I am not connected to any of the network.
So if you didn't assign and you were not connected, you would see 169.
Yes, if I don't connect, or even if I'm connected, okay, I'm connected to the network. I was connected to this network for last 1 year, but suddenly today, without making any change, I can still see 169 IP. Reason? The only reason is I didn't get an IP. The server could have been down. The server is down, again I'm not getting an IP. What happens if the cable is faulty? Cable has just gone down. Or the port connecting to the switch is not working. So there are so many factors that can influence in getting an IP address of 169.2.
Show. Unplug.
Which one?
The cable.
That's why I have put the 169 output here. I know you will ask. This is what you will see that 169.254. Okay, it's nothing like once you don't get an IP address, you will see here 169.2.
And that's it.
That's it, nothing else.
This is the only thing we need to remember in troubleshoot, right?
One of the thing.
Okay.
You can also give ipconfig/all to see more information.
Oh, thank you. This is exactly what I want.
So this gives you a lot of information. See, it gives you the MAC address.
Oh,
Okay.
this is the physical.
Yeah, that's
layer
the
one. No.
That's the MAC address is layer 2.
Layer 2, sorry.
Yeah, so you see, here is where you see the DHCP server IPs. Before you never saw anything. You just saw your IP address, subnet mask, and default gateway. That's it. But here in all, you will see your MAC address, you will see the type of your Ethernet card, then you will see lease period, which is associated with your DHCP again, which means you're getting an IP automatically, right? Now, whatever you get automatically, it's not a fixed long-term, a permanent IPs. Okay, I would say it's not a permanent IP that you get. It comes with the expiry time. Because if you're having a seminar, okay, now it's a one-day seminar, and you have 100 guests or 200 guests. So they are here for 2 hours and they leave.
Yeah.
When they come, they get an IP and they don't come back after for next 1 year. Now, if they're getting that IP address permanently, now this DHCP server has already allocated and it doesn't have any other IP address for the next day seminar. So at that time, what I do, I keep the lease period as 6 hours. So people come, they stay for 2 hours, they finish the seminar, they can still be hanging around for another 4 hours. I just give them a freedom. But after 6 hours, that's it. They're not going to get an IP address.
How do you control it? Or you don't,
It's
by itself, default.
No, it's not by default. It's there. There is a configuration in the DHCP server where you can specify how long you would like to have. 8 hours, 1 day, 2 days, 3 days, 4 days. It's all up to you. Okay, so you see the DHCP server here. IP address, you will see DNS server's IP. So a lot of other information you will see for your wireless and wired networks. Again, you will see the adapter information. Okay.
So we have forgotten, how does the DHCP server decide on the pool? Like how does it come up with the pool of IP addresses? It's based on what you bought? Like,
Logically, it's free.
Oh,
you know, like what's the range the DHCP server is going to assign from a pool, right?
Like this.
Yeah, so how does it decide the pool?
Just like this. Is a question based on this? Like I have 2 pools. How users are getting IP from this?
So like from for example, Internet, right?
Yep.
Every time you're going to plug in your laptop to the network, DHCP is going to assign you an IP address, right?
Yeah.
But from which range is it going to assign?
I have already configured that.
You already have, you have to.
I have to. Otherwise, you see 169. If I don't configure anything on the DHCP server, you get 169. Because the moment you connect, it's going to request for an IP. The DHCP server is going to say, sorry, no one has configured anything, so no IP. So you get 169. We have to go and manually configure. This is the starting IP, this is the ending IP. That's all your DHCP server needs. Starting IP, ending IP. And
If this will not work in all the computers, that I'm pretty not gonna work.
sorry?
It's not have
If it is not there,
Yeah, all the computers.
everyone are going to have 169.254. Now, if that is the case, they will still communicate. That's a small tweak to that. Now, imagine there is a company. There are 100 users in the company. The DHCP server is completely crashed. So DHCP server is not giving an IP address to anyone. So what do you see on all the 100 devices? 169.254. Now what Windows has said is, okay, even if you don't have a valid IP, even though you have 169.254, which is not a valid IP, now I give you a permission to communicate with others who have 169.254 IP. Because when I said previously, I said if you have 169.254 IP, you cannot communicate with anyone else who are in valid network. Now, if all the 100 doesn't have an IP, they are all having 169.254 IP. Now they are part of a network. They can communicate within themselves, but you cannot go online. You cannot access anything else. Still, Windows has given you some kind of flexibility. Okay, so that is possible with Apipa. Whoever has the same 169.254 IP, you can communicate. Okay, so that is DHCP. Now, next is the layer 4, what we were talking about initially today, TCP. We never discussed about that in detail, but all we know is layer 2 is where you see the MAC address, layer 3 is where you see the IP address, and layer 4 is where you see the port numbers. Okay, this is the most important information that you need to remember. Port numbers are there at layer 4. and you have the two major protocols called TCP and UDP. Transmission Control Protocol and User Datagram Protocol. These are the two major protocols that is available in the whole networking. Everything comes under TCP. Okay, it's layer 4. Yeah. So
Transmission and your ones?
Transmission Control Protocol, User Datagram Protocol. All right. Now, before I get into that, I just want to let you know how this is structured. Now, I said this is the parent protocol. Most of the protocols comes under this TCP IP, which means, what are they? So, what you need to understand is, we have, I said, okay, 65,000 whatever protocols, port numbers. Now, majority of the well-known port numbers or majority of the protocols that we use every day, now they all come under one umbrella or parent protocol called TCP IP, which is nothing but this TCP, which is layer 4, combined with the IP in layer 3. Okay, this IP and TCP, we combine to call it as TCP IP suite. Now, you can ask me, okay, do we have something called UDP IP suite? We never have that, because we don't have any major protocols. No, I will not say any major. We don't have number of protocols. With respect to the number of protocols, the UDP has very, very limited. So we never call, we don't have anything like UDP IP suite. UDP is ignored. TCP is the biggest thing. Okay, so majority of the protocols that we use every day, important protocols, comes under TCP. Only one protocol that is purely UDP, and that is very big, is DHCP, the one which we talked with earlier. Now, DHCP is the only major protocol that is UDP. But apart from that, all major protocols are TCP. That's why we say TCP IP suite. Okay. So all these protocols come under TCP IP. So that's why TCP IP is the biggest thing that you will learn in networking. Okay. There are volumes and volumes of books written on TCP IP alone. Okay. So everything comes under that. All right. All right. So TCP, Transmission Control Protocol, UDP, User Datagram Protocol. These two are entirely different protocols. They are just opposite. Now we'll just talk about similarities, and there's no similarities though. Differences between these two. TCP. We call TCP as a connection-oriented protocol. TCP is called connection protocol, connection-oriented protocol. UDP is connectionless. This connectionless doesn't mean it's wireless. Okay, it's still wired. Now, what it means by connection-oriented and connectionless? If I have a PC here called PC A, if I have another PC here called PC B. Now, if I want to transfer a file from A to B, okay, and if I'm using TCP as a protocol, I have just two choices. Either I can use TCP or I can use UDP. Now, imagine I have chosen TCP. Now, what happens is, even before I send the first packet to B, I make sure B is available, up and running now, and B is ready to accept the files. these two things I make sure at least before I even send that Word file. So for example, I have a Word file to be sent to B. Now before I actually send this file, I logically connect to this PC at layer 4 through TCP. TCP helps me in that. TCP will check with B, hey, are you up and running? B will say yes. Then A is going to say, I have something for you, and this is the size, and this is the time that it will take for me to send it. Are you okay with that? Now B is going to say, yes, I am fine. Once B makes sure that yes, I am fine in receiving that file, then A sends that file. So this logical connection is what makes TCP connection oriented. Now, imagine I'm using UDP to send a file. Now, UDP doesn't care about anything. UDP doesn't care whether B is switched on or switched off. UDP's part is just to give it. Okay, you gave me something to send. I will send it. That's it. My job is done. I am not special like TCP. I'm not going to do something out of the box to make sure he's ready and he's available to take it. So TCP is connection oriented, UDP is connectionless. Okay. Now, what else? Connection oriented, connectionless, TCP, security wise. So anything else? Okay. It's reliable. TCP is reliable and UDP is unreliable. Now, what makes TCP to be reliable? TCP has a unique feature. Say for example, you are sending a Word document, and this Word document is 1 MB. Okay? I think you are pretty sure that we can, have you heard about the term called MTU? Maximum Transmission Unit? The MTU for Ethernet?
Yeah.
Yes? $1,500 bytes. Which means whatever packet you're sending from your PC, be it any kind of packet, the size can be only of 1,500 bytes per packet. Now, if someone asks you to take a Airbus 380 from Markham Lawrence to Markham Steels, can you take it on this road? No, it's not possible because the size of the Airbus 380 is so huge that it will not fit in this road. So what is the only way? You disassemble it. Okay, you take it off. You rip off the wings, engine, you take it off, then you ship one by one. You transport it one by one. Then again you reassemble. Okay?
1,500 bytes.
Yes. Now here we send different kinds of packets with different sizes. Now the cable that is going, that it's not like it can accommodate any kind of size. There is a standard size, which is 1,500 bytes for Ethernet. So what happens if you send 1 MB file? 1 MB file is not sent in one packet as 1 MB. It is chopped into many number of packets, and each packet with a maximum of 1,500 bytes in size. And every packet is given a number, sequence number. Okay, this is packet number 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. So each packet goes, and once B receives all those small packets with 1,500 bytes, it reassembles. Okay, 1, then I have 2, then I have 3, then I give it to the upper layer, then you see the whole document again. That's why if this is not there, what happens? If you send an email to someone else, they will see thanking you regards in the first line, then they will see hi in the last line if the packets are rearranged. TCP is working on it to make sure it is looking, it should look as how you have sent it. Okay, so coming back here, why we call TCP as reliable? when TCP has, okay, just imagine TCP has broken this Word document into 10 different packets, small packets. Now first it will send packet number 1. It will not send packet number 2 immediately. Why? It waits for an acknowledgement from B saying that 1 has been received. Only when it receives an acknowledgement for packet number 1, it sends packet number 2. If it doesn't receive an acknowledgement from packet from B within a stipulated time period, it will resend the packet number 1 again, thinking that it got lost somewhere. It's reliable. It waits for an acknowledgement. Every packet has to be acknowledged. That's why all your online banking is safe, because they use TCP. Okay? Packets are not lost. If you are saying, okay, transfer amount from my account, $500 to my friend's account, okay, what happens if 10 drops off? Only $50 gets transferred, right? TCP makes sure even that 10 gets dropped off, it resends that again. Okay? UDP, no acknowledgements. You send it, forget it. Okay? So if it gets dropped, I don't mind. Okay, so that's how UDP. Okay, UDP has a lot of disadvantage. It has to be, there has to be something positive, right? Okay, there is something positive because it does nothing. Okay, TCP does everything. All the hard work is put by the TCP. Since a lot of work is put by TCP, it's tired. It's going to be a bit slower than UDP, and this is faster. Now that's the only feature that is a highlight for UDP. Why? Say for example, you are expecting an email from your friend. He said, okay, I have sent it. You have the patience to wait at least for 2 to 3 minutes. Okay, yeah, let me wait. At least let me click the refresh button. Within 2-3 minutes, I will receive my email. So I have my patience level that much. When you are watching a live program or live match, your patience level goes down. Okay? So what do you need at that time? You need the speed. You need to know what is happening at that moment. You don't care about some packets here and there getting dropped. You are watching a live match, okay? And suddenly for a fraction of a second, the screen just got disturbed, okay? Because packets were dropped, it just went black and came. Will you go and pick a phone to call Bell saying that, okay, there was some packets dropped, please resend it again? No, you just move on. So here the need is fast, the speed. So there you use UDP because UDP doesn't do anything. When it doesn't do anything, things can be faster. But TCP keeps checking each and everything. If there is a packet drop, okay, I wait for an acknowledgement until the next. So I'll be slow. So that's why when you send an email, just take some time, right? Because it is doing a lot of calculation. So for VoIP, video conferencing, for live streaming, you use UDP. For anything that needs to be reliable, you use TCP. Okay? So those are the information with respect to TCP and UDP. And next is the ports. We discussed something about the ports. Now, you don't have to worry much. I mean, the data what is given in the book is more than what you need, but I'm just explaining you what is required for the exam. Now, ports, I said, so under TCP is what majority of the protocols come under, and they all have a port number associated with it. Okay, so in general we have 0 to 65,535 ports, which altogether makes 65,536, and out of that 0 to 1,024 are called well-known ports. Okay, so majority of the protocols that we use every day, for example, browsing, email, all the stuff, YouTube, LinkedIn, everything is under the well-known ports. Okay, so those protocols comes under well-known ports, and they have port number which are under 1024. Okay. Okay. there is at the bottom. So there I have given you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. Now, minimum requirement is you need to know those port numbers. You may be asked in the exam. Okay, what is the port number for whatever protocol it is? Okay. All right. FTP. Now FTP actually uses two ports, 20 and 21. 21 is missing there, but 20 and 21 is being used for FTP. It's called File Transfer Protocol. Whenever you watch YouTube, you are using that protocol, FTP. If you want to check, this is your computer screen, and if you type youtube.com and if you click on any video, now until that video gets loaded, you will see a small information here, connecting to, transferring to, and it will say FTP. For a fraction of a second or a couple of seconds it will say, connecting to FTP this site. Okay, so it uses FTP, File Transfer Protocol. On the screen, yeah, just below your video.
Yeah.
Until the connection is established. Once the connection is established, you will not see that information.
It's not in the browser window, it's in the video window.
It's in the video window. Probably the video is like this, and you will see like here.
Okay.
It will say FTP.
So that's FTP. I thought FTP was
That's FTP, to transfer files.
I thought FTP was like when we have a problem with our our software programs and stuff, we have to send our database. They use an FTP port to upload it.
Yeah, still that's the same. This is one of the application. In an office, we have servers. Now, what are servers used for? Servers are used for storing a lot of files. You have a dedicated device where you dump all the files, and you have all the employees to access files from that server whenever they need it, right?
Yeah.
So whenever they need a file, they have to retrieve that file from the server. So for that retrieving, you use FTP. Yeah, this is one of the applications. Just an example, I'm saying, YouTube. Now SSH. SSH stands for Secure Shell.
So 20 and 21 you said, right?
20 and 21 are for ports, FTP. Now, imagine you buy a T-Link or TP-Link or Bell router or whatever. When you take it out of the box, you will have an instruction booklet which says, okay, for your initial configuration, connect your router to your PC and open a browser and give the IP address 192.168.1.1. So you get a page and you start configuring it. This holds good for Soho routers. If you're going and buying switches like that, Cisco switches or routers, now there is no default configuration that comes with switches and routers. There's no booklet that will say connect your PC to the switch, open a browser and type 192.168.1.1. No. The reason, there's no configuration on that. You have to go and configure everything from the scratch. So if there is no pre-configuration, you need to go and do something. So for that, there are three types of configurations. One is console. Did I show you that blue flat cable, console cable or rollover cable? I think I showed you in the last class. So it's a blue cable. So that's a console. Is one way you take access. Now, imagine you are a network admin working for Bell. Okay, you are situated in headquarters, Toronto. You are in Toronto office. You get a ticket saying that one of the router in Vancouver is having some issues. You are the only network admin. Can you travel to Vancouver for that? No, it is not required. Reason? Sitting in Toronto, you can take access of that router remotely. Okay, all you need to do is you need to have the IP connectivity to that router. That's it. You can take the remote access, just like your team viewers. You take a remote access of someone else's computer, right? And you start configuring the other person's monitor, whatever. Now, you can sit in one place and take remote access of any device in the world. Okay. Now to achieve that remote connectivity, again there is a protocol to help you in that. The protocol, there are two protocols. One is called SSH and the other one is called Telnet. There are two protocols designed to help in taking remote access of other devices. It could be any part of the world. What is the difference between these two? SSH stands for Secure Shell, which means it's secure. We do not recommend you to use Telnet in organizations because whatever you send, it's sent in clear text. Anyone trying to capture your packets, they will see everything. In Telnet. Telnet is not secure.
Yeah.
SSH is secure. Okay. Now, how it happens? Say, for example, buddy. Okay, this is one of the tools that we use to take remote access configuration. This is one of the most widely used tools in the world called PuTTY. Okay, now you see here, you see the word SSH and you see the word Telnet here. So if I am a network engineer, I am in Toronto, and if I want to take an access of a router which is in Vancouver, all I need is that router's IP address. I will put the IP address here saying what 10.10.10.1, and if I select SSH and if I click open, it opens for me. I am inside that device.
But you have to have the, I guess, username, password, all that, right?
Once you get in, you need to have the username and password.
Oh.
Not here.
No.
Okay, but since I am the network admin, I should have the username and
How do
password.
you get here to this window again?
This you have to download the setup file, PuTTY. Okay, PUTTY, PuTTY. It's free. I just downloaded it. My laptop didn't have it. I just downloaded it. It's a very small file. Okay, so all you need to do is you need to give this IP address. You can select. So when you select, now SSH is selected, right? You see the port number 22.
Yeah.
If I go and select Telnet, it changes to 23. So that's the port number used for it. Okay. Now this is a serial, which means the first console. For any brand new device, you cannot do SSH, you cannot do Telnet because they don't have an IP address configured.
Yeah.
So you have to do a serial connection. That's where your console cable comes into picture. Okay, so at that time you don't have to give any IP address. Okay, because it doesn't have any IP address. You can just directly connect your laptop to your router. So what we use are serial, SSH and Telnet. But for exam, you don't have to worry about the serial. You don't have to know the SSH and Telnet. Okay. So these are various uses of protocols. SMTP, we already discussed. Simple Mail Transfer Protocol to send the mails. Okay.
That's the one that is
Yeah.
not used anymore. No, IMAP, right?
SMTP is always used. That's the only protocol you have to send emails. There are protocols to send and different protocol to receive emails. If you want to receive, we were using IMAP before.
Oh.
Now we started using POP3. So IMAP is not recommended anymore. POP3 is what is recommended to be used. Okay. DNS. You have to be aware of the protocol called DNS. What does DNS stands for? Domain Name System.
For a question, SMTP is for to
Send the email.
Send email, but not Google, Gmail, or anything like that, right?
They still use
Or
any email.
but that's in their server, right?
Yes. They are vendors. Gmail, Yahoo Mail, they are vendors. But still they work on the same protocol called SMTP to send the email.
For me to write an email on my computer, connect to Gmail, that's
HTTP. You connect to the server through HTTP.
HTTP.
You send an email through SMTP.
Right.
And you receive an email through POP3. DNS, Domain Name System. What is it used for? Anyone heard about DNS server? It's the most widely used protocol by you all, without any doubt. Whenever you open a browser, and if you say google.com, will you think your computer is going to understand this word, Google? No. Your PC doesn't need a name. It needs IP address so that it can convert that back to a binary number. But humans, we go for comfortness, right? We cannot remember each and every website's IP address. So we give a name to those IP addresses, like google.com. But google.com is associated with an IP address, say 66.10.20.21. So when you type google.com in the browser, the first thing what it does is it goes to the DNS server and requests what is the IP address for google.com, and DNS server will respond, okay, this is the IP address. So DNS server is nothing but it's a database which has all the mapping of name to IP address. This name is called domain name. Google.com, Facebook.com, LinkedIn, Twitter, these are called as domain names. The DNS server is going to have the information of domain name along with what IP address it is associated with. If DNS server IP is not configured in your PC, you will never be able to go online. All you will see is page cannot be displayed. That's another troubleshooting.
I think it's 10 point something, Google, right?
It's yours. It's a private IP, right? How can it be Google's?
No, Google.com is or Google.ca have a specific IP. It's easy to type in.
There are something called public DNS. I think you're talking about this.
8 point, that one.
That's public DNS server. If, like for example, like a company like Sysnet, I don't want to spend some money in buying my own dedicated DNS server. So Google gives me an option. Okay, use our server. 8.8.8.8, free of cost. It's public, so it's free of cost. Okay. So that is DNS. HTTP, we all know, used for browsing. Whenever you open a browser, you use protocol called Hypertext Transfer Protocol, HTTP, port number 80. POP3 IMAP we just discussed. Now, whenever you want to do something confidentially, like online banking or logging into your email accounts, now your browser will turn to HTTPS, green. Now that means it's secure now. Okay, many call it as Hypertext Transfer Protocol secure. It's not secure, it's SSH, HTTP over SSL. Okay, that's the actual name given to it. But many call it as secure HTTP. Okay, but it is actually HTTP over SSL. Now RDP. If anyone have used TeamViewer or anyone have used this one?
The Windows remote desktop.
Yeah. This one, remote desktop connection. Now you can remotely take access to a different device through Windows, okay, and that is through a protocol called RDP, remote discovery protocol, something like that. Okay, so that's the port number is 3389. That's another one that you need to know for A+. Okay.
It's not up to 1024?
Sorry?
It's not up to 1024?
Yeah, there are some port numbers which are beyond. Very few.
3394, yeah?
3389.
89.
Yeah.
Can this program turn on in computer while it's off?
Why it is off?
Um,
You mean PC is turned off?
No,
I mean,
turn
my
it
PC
on.
would turn off.
Okay.
I try to.
No.
No, wait.
Yeah, some.
In the case okay, I have a PC here. I want to take access of another PC,
Yeah.
and that PC is turned off.
Yes.
Okay. So you are going to take a remote access of that device.
Yes.
Not online.
How?
Some motherboards do that. My motherboard does that.
How?
Through the NIC card.
It's from the future. You don't
Through
understand.
the NIC card. So, it's from Asus. So, my phone, if I want to connect to it, I can turn it on and return on. I can have access
That's
to
like
it.
power over Ethernet. Your next online
that's different.
already. That's different.
That's
Why-
different.
why
That's
did-
different. That's not RDP.
I know,
but there is
but-
some devices that do that.
What? To turn on the device?
To wake it up?
To wake it up,
Okay,
yeah.
come on, that's a different thing. You're talking about waking up a device. I'm not talking about waking
And
up a
take
device.
control.
I'm talking about taking control of that device to configure something, to do something on that device, not
If it's on.
waking up.
Okay.
Not waking
Only
up.
if it's on already.
RDP
If not-
works only when it is on and you have the port number there enabled, whatever. Only then it works. Otherwise, it doesn't work. If I don't want anyone to take RDP access, I can go and shut that service in my laptop. Even though if it is on, no one will be able to take RDP access to my laptop because I've shut the service here. Okay, so that is entirely different. As of now, there's no technology that can work on that. Okay, when it is shut down, no one take a remote access of the other device.
You have to.
Until you have another technology which can help in waking it up, turning it on, that's different. Yeah.
So internally in your house, you can use RDP between computers?
Yeah. Of course.
So you just have to put the IP address of your computer?
Yep. Yep. Yes.
I think it's enough.
Tired?
Sometimes you have to configure something in the back end of your computer to accept RDP branch.
You have to add your username in that local domain.
Yeah, that's the domain thing, not back of your device. So what do you mean by back of the device?
Like some computers you can RDP to it,
Yeah.
and some computers you cannot RDP. You might
Everything depends on the application side, not on physical. You don't do anything physically. You don't have to add anything physically. It's on the application side, like domain name. You have to be on the same domain.
Same domain, yeah. Let's say I have some computers at work. They are just on the same domain.
Uh-huh.
You can RDP to some. For some reason, I cannot RDP to.
Probably the policy, group policy may not allow you to do it. Group policy may say deny to these specific users. Even though you're on the same domain, I can get into the Active Directory and say these specific users are not allowed to access this, even though you are part of a domain. I can still do that. I can,
In the Active Directory.
yes, Active Directory, AD, they call it as. It's called the AD.
Yeah, but let's say I'm the administrator. Still.
You are the admin.
Yeah, let's say I'm the admin.
You should have the access then. Admin should have all the access.
I thought it was something on the other end, on that computer,
Mhm.
that I need to turn on, like
Mhm.
firewall or turn off or something to RDP.
So you were not able to RDP into it. So even though okay, so that is something different. Now if you are an admin and if you cannot RDP into it, now check whether that port number is allowed or not. Okay. Now where are the port numbers used? What is these port numbers are used so heavily. I said during the initial class, I said, okay, layer 4 example is a firewall. Layer 2 switch, layer 3 is a router, layer 4 is a firewall. Now if you are a network admin and if your boss comes and says, okay, due to some kind of testing or some kind of shutdown, now I don't want anyone to do browsing for next half an hour. I want all the 200 employees of this company not to browse.
L4 delete.
Okay. Where what? Okay. You're deleting your own information on the PC. Nothing else will happen. Okay. If that is the requirement, now what you can do, whom you can turn to for help? Firewall. Firewall works on port numbers. Log into your firewall, say port number 80 and 443, you go and disable it for next 30 minutes. No browsing, because all the traffic within your office goes out through that firewall. When a packet leaves a firewall or enters a firewall, it checks the port number. If it matches 80 and 443, it blocks. No one will have browsing. And after 30 minutes, I go and enable it, everyone will have browsing. So, granular security I can provide with the help of port numbers. Okay, if I can allow a specific port, I can disable a specific port. If I see someone trying to access or hack my website, my internal information, some intruder is going to get in. And if I suspect he is going to use port numbers between 1000 and 2000, I will go and block all 1000 to 2000 ports. No one can enter into it.
Except this guy.
So that's where the port numbers are really used. Okay, they are heavily used, but in general, when we learn the basics of networking, we don't talk much about it. We talk a lot about IP addressing, but ports are used when you learn security. That's when they come, because firewalls are security devices. Okay, so that's
You're
where
right. You're right. We had a project that we was changing the devices, like for payment station. Like you said, I looked like an alien in one of the meetings because they were talking about this. They say no, to the main guy, he said no, you have to give me the ports.
Yeah.
The name was certain ports, so when I install the machine,
Yeah.
accept the
Yes.
payment.
Otherwise, so that's why you have 65,000 ports, because there are thousands of vendors producing thousands of different devices. Xbox, your PlayStation, they are all not using well-known ports. They are using some random ports. Now, if someone wants to, by default, these are disabled in your office. Say, for example, your vice president is busy. He likes to play PlayStation. He cannot just bring in a PlayStation and start playing, because that will be denied. He has to let the admin know, okay, I'm going to play, please allow me these ports. So then network admin goes and allows whatever port number it is, then he can play.
Firewall. Right?
Yeah. So it works like that. Okay, as per the request, we will stop here.
10 minutes.
Now,
already. 10 minutes. Exactly.
10 minutes.
wow.
A lot, man. A plus is a lot.
We cannot finish it one day.
This is like a concentrated juice of A plus.